So hello everyone, welcome to the introduction video of our this project, and our project name is Smart Manufacturing Machines Efficiency Prediction. So basically you will be predicting the efficiency of machines here. Okay, and what is this smart manufacturing basically? Smart manufacturings are AI powered machines which doesn't require manual labor, right? Basically, if I have to tell you the most frequent use case of this smart manufacturing machines, it is in car making. Okay, you can see in the image here. Generally in movies also you have seen Iron Man something. It automatically does its work, right? So no human is required, they are automatically fed to perform a specific task. Okay, and in some of them AI is also used, but so these are called smart manufacturing machines, right? Basically these are used in industrial purposes, basically. Okay, you will not find these machines in someone's home. Okay, these are all industry level machines. So in this project, we will be predicting the efficiency of these machines. Okay, and how we will predict efficiency based on the sensor data. Okay, basically these machines have their inbuilt sensor which generally records their temperature, frequency, and other factors also. On the basis of that factors, we will predict what is the efficiency of that machine, whether it's high, it's highly efficient machine, it's not efficient, it's very low efficient. Okay, it is taking too much power, but doesn't it is not producing that much good quality products. Okay, these all are manufacturing machines. Okay, make sure I am telling you. Okay, so I think you have got the gist of the basic introduction of the project. What is this project about? Okay, let's move to another slide. The highlight of this project. So this project is gonna be our GitOps project. Now, what is this GitOps project? GitOps basically means when GitHub, okay, when GitHub act as your truth source. Now, what do you mean by truth source? What do you mean by truth source? I will not tell here. I will tell during the workflow. Okay, so GitOps is a project when your GitHub acts as a truth source. How it's different from the other project that we have done? Okay, so basically it will be a CI/CD deployment project, but using your GitOps deployment techniques, right? And the other thing that you will be using. Okay, so you have used Google Cloud Run, you have used Google Kubernetes engine, but you haven't used till virtual machines. So in this project, you will be using Google virtual machines. Okay, inside that Google virtual machines, we will be installing Minikube. I already told you in the project 5, right? That please run that Minikube, learn that Minikube and kubectl part. And we will be installing virtual machine is just like renting a PC. Okay, you are just renting a PC online. Okay, and you will be installing that Minikube inside that virtual machine, kubectl inside that virtual machine. You will also install Jenkins inside that virtual machine, and then you will install ArgoCD. Okay, that last thing is ArgoCD, right? Let me show you. This is ArgoCD. What is the use case of all this? Okay, virtual machine is your, we can say, where is my cursor? Okay, it is just like your PC. It is just like your cloud rented PC. Minikube is your, till now, what you have done, you have used pre-built Kubernetes cluster that are provided by Google Kubernetes, right? That is your Google Kubernetes engine. You just click on new cluster and you get your cluster, right? But this time you will be creating your own cluster using Minikube. So this is a new thing. Okay, so inside virtual machine you will create your own cluster. So it will be your own it will be your own Kubernetes, not Google Kubernetes. You can name your Kubernetes on your name. Okay, so for suppose your name is Rahul, so you can name it Rahul Kubernetes. Okay, like this. Okay, so you will be creating your own cluster. Then for Jenkins will be used for your CI part. Basically, CI/CD made of two terms: continuous integration, continuous deployment. So Jenkins will be used for continuous integration. Then you have Argo CD. It will be used for CD part. Okay. So Jenkins will integrate your code. Argo CD will deploy your code to your Kubernetes. Okay. You can see Argo CD is deploying the code to uh, Kubernetes. Okay, so it will be a fun project. You can use any other tool. Okay, you can use GitHub Action for CI part. You can use GitLab for CI part, or you can use Circle CI for CI part. Okay, but for CD part, the main thing will be ArgoCD. And ArgoCD basically helps in our GitOps. Okay, so I will tell you during the workflow how this ArgoCD is most important, how it is different from a normal CI/CD deployment. Suppose let's take two scenario. In one scenario, you are doing all the CI/CD deployment using Jenkins that you have already done in the project 1 and 2. And this scenario, this project 9, in which you are doing half part using Jenkins, that is your CI part, and the CD part using Argo CD. Okay, and Argo CD has the name Argo CD. So Argo CD can only be used for continuous deployment only. It cannot be used for continuous integration. It is specifically designed for continuous deployment only. You can see Jenkins can do both the things, integration also, deployment also, but Argo CD can't. It is made for deployment only. Okay, so how the deployments will be different if you are suppose doing all the deployment CI/CD deployment using Jenkins, and if you are doing CI with Jenkins and Argo CD with CD with Argo CD. So how these will be different, we will discuss them at the end of the video when we have discussed all the workflow and all. Okay, after that I will tell you, or I should tell you now only. Hmm. Okay, first of all, let's discuss these data set and all. After that, I will tell you. Okay, uh, here is your data set. So this is the intelligent manufacturing data set. It is around, I think in the zip file, it is around 9 to 10 MB in size. It has a good number of rows also, more than I think 2-3 lakhs. And you can just download it from Kaggle. I've already provided in the link, and I've already provided the data set in the resource section. So just extract the zip file from the resource section. You will get a data folder. Inside that, you will get data.csv, and you can move ahead with your project. Okay, so you will get this data only. But if you want to download it from Kaggle, just go to Kaggle, make your account, just download this data set. Okay, you can see real-time sensor network and production data for AI driven efficiency analysis. So these are all smart manufacturing machines. Okay, where AI is being used, and we are our features will be the sensor data. Okay, on the basis of what we will be predicting the efficiency, right? So this is your data set. Then the use case of the project. Okay, the use case. So first of all, before discussing use case, who will be our target audience? We should discuss the target audience, right? Who is our target audience? Industries. Which industries that uses uh, this smart manufacturing machines? Generally, car industries, automobile building industries. Okay, most of the smart manufacturing machines are used in automobile manufacturing industry. Okay, because most of the things there are automated by your these machines only. Okay, so these are our main target. So first of all, what you can do basically, you can do predictive maintenance. Your first use case and the most useful use case is predictive maintenance. Make sure I don't know if spelling is correct or not. Okay, uh, basically what is meant by this predictive maintenance, basically you can predict when these machines are likely to fail. Okay, suppose a machine is not behaving that good, right? It is consuming too much power, but efficiency is still low. Okay, and if it is requiring too much money, consumption cost, and it is failing again and again and not providing us the desired result. Okay, you can replace these machine with the more efficient machines. So it will help you to lower your cost also. Okay, so it will help you in cost management also. Cost management, instead of using a low quality machine which is providing you low efficiency, you can go with the high efficiency machine. Okay, which does the same thing but higher efficiency. It consumes less power. It has a very less error rate. Okay, it produces more products in an hour, right? these all features you will get inside your data set, right? So I'm not telling from anywhere. It is from the data set only. Okay. I think basically these two are the main use case: maintenance and cost management. Basically, using predicting, sorry, using our project, a company can predict which is their which machine has the lowest efficiency and which has higher efficiency. And if a machine has lower efficiency, it is likely to fail. Okay, it is likely to fail. So company can replace those machines with the newer machines, so it will help in cost cutting. Okay, and you can do maintenance of your machines also using this. Okay, so I think these much are mm, the only use cases I can think of. Okay, if you can think of any other use case, please provide those use case in the comment section. Okay, if you are giving the review, you can just, in the review part only, you can just give the suggestion for the use case. Okay, now coming to the workflow. But let's first of all, instead of going to the workflow, I will tell you that part. Suppose if you are doing the CI/CD using Jenkins only. Okay, suppose you are doing CI/CD whole using Jenkins. Okay, no ArgoCD. Like in your project 1 and project 2, right? You have used Jenkins, right, for CI/CD. Uh, so suppose this is your pipeline. Okay, this is your pipeline, like this CI/CD pipeline. Okay, so this is basically your, it is building your Docker image. Okay, build, then it is pushing your Docker image to whatever GCR, Docker Hub, anything, and it is deploying your image to Google Kubernetes engine. Okay, so this is your pipeline. It has 3 stages. Suppose your pipeline is first time. Let's take first time you run this CI/CD pipeline. Build got executed successfully, push got executed successfully, deploy got executed successfully. Now your app is running on Kubernetes. Okay, it is running. It is running successfully. No problem. Suppose you made some changes in the CI/CD part and it run it for second time. So build place successfully, push takes successfully, but it is not deployed successfully. Maybe you made some error in the deployment code or anything. It can be any error. What will happen, since it was not deployed? Your app will stop running. So it will stop running. Your pipeline was failed and app was stopped running, like this. Okay, so even one step will break, whole pipeline will break. Okay, now what is the benefit of using, suppose if we are using CI with Jenkins, okay, and CD with ArgoCD, like this. So what is basically happening here? Uh, this is your PC. Okay, suppose here you have all your code, and you pushed all your code to your SCM. SCM can be anything. In our case, since it is a GitOps project, it is obviously GitHub. Okay, so our GitHub will be the truth source. Now what I meant by truth source, basically truth source means it will store all the commits. You commit the things, right, in the GitHub, so it will store all the commits. Okay, generally GitHub stores all the commits, right? So it will store here also, it will store all the commits. Now using Jenkins, you made a CI pipeline. Okay, integration pipeline. Basically the build and push. Okay, you build your Docker image and pushed it to whatever Docker Hub or anything. Okay, you pushed it to Docker Hub, right? So all these things will be recorded in your GitHub. All these commits will be recorded in your GitHub. So that is what we have meant by sorry, it is record. So this is what I meant by GitOps or truth source. Okay, So these all the commits are recorded. Okay, good. Now what ArgoCD will do, now your image is pushed, right? So it will now take place your push, sorry, deploy part. It will execute your deploy part, and now your app is running. Okay, and your deploy is also recorded. This deploy commit is also recorded. Record commit. Okay, and this GitHub is your truth source. Now, what is happening here basically? Uh, so basically, this is your pipeline, right? To tell you like this. Okay, so these two are being done with Jenkins, right? And this one is being done with ArgoCD. Okay, so this is your deploy part, this is your push part, and this is your build part. So build and push are being handled by Jenkins, and deploy part is being handled by ArgoCD. Okay, so suppose you tried it for first time. Okay, build success, push success, deploy success, app running. Good. Now you run it for second time. Build success, push success, deploy not success. So basically your deploy failed, or maybe any step failed. It's not deploy will fail. Okay, even your push can fail, anything, but your app will still be running. Okay. So what app will do basically, Argo CD will detect that this pipeline has failed. Okay. Argo CD will detect. Argo CD detects. ArgoCD detects this pipeline has been failed. Now, what it will do, it will roll out, or we can say it will redirect to your previous commit. This was your first commit pipeline, right? And I told you every pipeline is being committed to your GitHub. Okay, every pipeline is being stored in your GitHub. GitHub is acting as a truth source. Now, this second pipeline failed. Now, which was the uh, it will ArgoCD will check which pipeline is the most successful pipeline before this failed pipeline. So it will check before this first pipeline ran successfully. So it will run first pipeline again, and running pipeline app will still be running. Okay. So it will redirect to the first pipeline again. Okay. As soon as it detects this second time pipeline have been failed, it will redirect, or we can say roll out to the first pipeline. Okay, in this way your app will not never shut down. Okay, suppose if you have a company, okay, and you are making any change and that pipeline failed, your app is now shut down. Okay, so it can cause inconvenience to user. So in this case, this type of pipelines help. Okay, that's why Argo CD is different from a normal Jenkins CI/CD pipeline. Okay, so I hope now you have understood what is the difference between a normal Jenkins CI/CD pipeline and a pipeline with Jenkins and Argo CD. Jenkins is optional. You can use GitHub Actions also for the CI part. You can use Circle CI, GitLab CI, anything. Okay, but for the CD part, Argo CD. Okay, you will be having fun during the making of the project. Okay, although Argo CD is bit complicated to configure during the VM instance but I've told you the most easiest way in the most easiest explanation. Okay, so I'm sure you will enjoy. Okay, so I hope now you are clear what is this GitOps, what do you mean by this truth source. Okay, basically recording the commits means the truth source. GitHub has all the commits for your all the pipelines like this, and Argo CD access them. Now coming again to the workflow. So our first step is obviously project setup. We are not doing any data ingestion here, because in the starting projects 1, 2, 3, 4, I have told every type of data ingestion directly from GCP, using Airflow ETL pipelines, okay, from Kaggle also. So if you want to implement, you can do that. But in this project, since our main focus is VM instance and all the configurations, we will focus on that only. So let's keep the starting page simple. So for project setup, in the project setup, what you will do, you will create basically your virtual environment. Okay, then logging files, custom exception files, SRC components, pipeline components. Okay, and basically you will define the overall project structure. Okay, you will define your project structure in short. Testing part. In this step, basically you will do all the things like reading the data, exploring the data, EDA, okay, generating graphs and all, doing data processing, doing feature engineering, doing model training, model selection, model evaluation, model testing, right? All the things will be in the Jupyter notebook testing, but it will be in a Jupyter environment using code blocks, right? You know about Jupyter notebooks, right? So basically, Jupyter Notebook testing forms the foundation for your upcoming steps. How? Your upcoming steps are data processing and model training. So data processing and model training are inspired from the Jupyter Notebook testing only. But the only difference is in data processing and model training step, there is modularity in the code. It is a more production ready code, right? Uh, it means here you will be using classes, object, methods like this. Okay, I hope you are understanding. But in the Jupyter notebook, on the other hand, you basically use code blocks that is not production grade code, right? So we need to create one separate file for data processing and separate for data model training, and we will do our data processing and model training, right? uh, and in the model training only we will form our training pipeline also, don't worry. After that, we have our user app building. Now for user app building, we will be using Flask, basic of HTML and shared GPT. Okay. Okay. So now what is the use of this user app building? Basically, user app building is required. Uh, you know about machine learning, right? You know about machine learning models, how to use them. But our target audience may not know how to use these technological terms, right? So you have to create a friendly app so that they can also easily access these models. They just have to input some parameters. Okay, they just have to fill the sensor data, and they will click on the simple predict button, and they will get their desired result. So that is basically the main point of our user app building. After that, we will move to our Dockerfile and Kubernetes manifest. Basically, we will create one Dockerfile, okay, and we will create one Kubernetes manifest. Kubernetes manifest consists of two files, basically your deployment file and your service file. You have created this before also, but previously you were creating them inside one file only, okay. You were creating Kubernetes deployment.yaml, but this time you will create one manifest folder inside that deployment file separately, service file separately. Okay, and Dockerfile are you are familiar with to Dockerize your project. After that, you will be doing data and code versioning using, of course, GitHub. It is a GitOps project, so GitHub will act as our truth source. So we will be doing data and code versioning using GitHub only. Okay, so I think this much is clear. Okay, if you want, you can do data versioning using DVC also. Nothing to worry about. Okay, but your SCM should be GitHub only. Okay, because GitHub will record all your pipeline commits and all. Okay, after that you have your VM instance setup. In this video you will be setting up your VM instance. What I mean by VM instance setup, basically, you will rent out a machine from GCP. Okay, you will create a VM instance, then you will install minikube inside that VM instance. Okay, you will install minikube. Okay, you will install kubectl. Okay, you will install Docker, because by default there is, that's an empty machine. You have to install according to your needs. Suppose if you have a window PC, if you want to install Docker, what do? You install Docker desktop. But these VM instances are Linux machines, so there's a different approach to install Docker inside them. Okay, and a different approach to install minikube, kubectl and all. Okay, so you will be installing all these in this video. Okay, it's a very important video. Make sure you watch it correctly, patiently, carefully. Okay, after that we have Jenkins setup. So in this video we will be doing our Jenkins setup, of course. So we will be installing Jenkins in our Linux VM instance, and doing all the configuration for our Jenkins setup and everything. Okay, so we will also be creating our firewall rules here. What are firewall rules? Basically, these are permissions so that you can access your uh, Jenkins dashboard. Because usually, if you have done project 1 and 2, Jenkins dashboard runs on 8080 port, right? So access that 8080 port, you have to set some rules inside that VM instance that I want to access that 8080 port. So we will be setting all those inside this video only, the Jenkins setup one. Okay. So make sure you watch this also patiently and correctly. Okay. After that, moving on, continuous integration. Okay. Now, after that, you have done in project 1 and 2 also. We will integrate our GitHub with Jenkins. Okay. We will create the access tokens for GitHub, integrate with our Jenkins so that all the GitHub code can be accessed by our Jenkins. Because in the GitHub only we have all the code. GitHub is acting as our truth source, as our SCM, source code management. So we have to integrate Jenkins with our GitHub, right? So once you're integrated, your all code in the GitHub will be accessed by Jenkins, right? After that, we will make our continuous integration pipeline. Now, what is this continuous integration pipeline? Basically, it is nothing but your build and push stage. I told you right now, build and push stages. Basically, in this continuous integration pipeline, you will create your .jenkins file. You have already integrated with the GitHub. Okay, then you will build the Docker image of your project. Then what you will do, you will push that Docker image to Docker Hub. Okay, push that Docker image to Docker Hub, right? So this will be your CI pipeline. CI pipeline is this much only. Just build the Docker image, push that image to Docker Hub. Your CI pipeline is done. Jenkins work is done. Now in the next video, since ArgoCD is not by default installed in any machine, you have to install the ArgoCD and you have to do a hectic configuration also. But I have told in the very easiest way for configuring your ArgoCD. So this is the most important, I will say. This is the most important video. Basically, in this video, you will be only doing installation of your Argo CD and configurations of your Argo CD. Okay, just like you did for your Jenkins setup, this will be your Argo setup, Argo CD setup. Okay, and this will be new also. Jenkins setup you are already familiar using your project 1 and project 2, but Argo CD is a new thing. Okay, so make sure you watch this patiently. This video requires patience. Okay, then you will write the continuous deployment code. Your continuous deployment starts here. CD starts here from Argo CD, right? And here you will write your continuous deployment code. It means you will basically, first of all, whatever the Docker container where it is running, you will install kubectl and Argo CD inside that container also. Okay. After that, you will sync your code, everything, your pipeline with your Argo CD app. Okay. So you will be making your Argo CD app in this step. Okay, Argo CD deployment and automation. What do you mean by automation? For automation, we will be using GitHub webhooks. Now, what is this webhooks? uh, Suppose if you want to run your pipeline in Jenkins, what you have to do? Suppose you have to go to the Jenkins dashboard. You have to click on that build pipeline. You have to click on that build pipeline. Then this pipeline will get executed. Then Argo CD will get executed, and then your app will be deployed. But you don't want to click that build pipeline again and again. You want, as soon as you push the code to your GitHub, that build automatically gets triggered. So this work is done by GitHub webhooks. So it is a hook. As soon as you push something to your GitHub, that hook will point towards your Jenkins to build that pipeline. As soon as Jenkins build that pipeline, Argo CD will get triggered, Argo CD will deploy, and after that your project will be deployed. Okay, so one thing leads to another using this webhooks. Okay, it's very simple. You just have to do some settings in the GitHub and all done within 5 minutes. It's not that much hectic, but you have to create your Argo CD app also here in this video. Okay, that's a bit challenging, I can say. Okay, So make sure you watch these videos carefully. Okay, after you have done this, you can access your app, and anyone can access your app from the internet, and just do the prediction. Happy learning. With this, your workflow is complete, and I hope you know now what is GitOps, what is all these. But if you are not still understanding what is this, just go through the videos. You will eventually understand. If you have followed me from the project one here, I'm damn sure you will understand. Okay. So with this, the introduction video is complete. Now let's jump into the project setup video. Thank you. Hello everyone. Welcome to the project setup video of our MLOps project. So in this video, we will be doing our usual project setup. So first of all, open your any local disk and let's create one folder here. Okay. So let's create one folder. Let's name it MLOps course project. I think it is 9th, right? So let's name it project 9. Let's open it and right click, make sure your VS Code is installed. Open a terminal. In the terminal, you will write code full stop and press enter. It will basically trigger your VS Code automatically. You can see your VS Code is opened. Now on the top bar, just go to a terminal, open a new terminal, and make sure your terminal is in command prompt. First of all, let's create our virtual environment. Okay, so I will write Python -m venv and whatever you want to name your environment. Let's name it venv only. So then press enter. Okay, so you can see your venv is created here. So it's taking time to set up your virtual environment. After that, we will activate our virtual environment. Okay, okay, done. Now let's activate. You will write your virtual environment name venv backslash scripts. You will go inside this scripts uh, folder, and inside scripts it is your activate folder, which will basically activate your virtual environment. So inside script, you will go inside activate, and you can see your vin is in bracket now. So it means your virtual environment is now activated successfully. Okay, so you have done your virtual environment part. Now since we are not doing any data ingestion here, I will be directly copy pasting the data which you have, I think, already downloaded. I have told it in introduction video, right? So you can just download the dataset from the introduction video resource section. Okay, so just download it. You can see mine is already downloaded. Uh, this. Okay, so you will also download that, and here you will create one artifacts folder. Artifacts. Inside artifacts, create one more folder which will be your raw. Okay, and just copy your data from here. Okay, and paste it inside the raw. Okay, so this is your data on which you will be working. In the next video, you will be doing the Jupyter notebook testing and everything. Okay, so I have already told about the data in the introduction video. Please see the introduction video. Okay, why we are not doing data ingestion? Because in the starting projects, your project 1, project 2, project 3, project 4 also, we have done different type of data ingestion, like using GCP buckets directly, using multiple GCP buckets, okay, using Kaggle also, and most importantly using data engineering pipelines, ETL pipelines. Okay, so I think you already know how to do data ingestion, so it's unnecessary to do the same thing again and again. If you want to implement the same thing here, do the same thing here. Just replace the previous steps with the steps of the project 1 or project 2. Okay. So now we have our data in the artifacts. Okay. Now you will be creating one file in the root directory only. Let's create one file, requirements.txt. Okay. Basically here you will list all the things that all the libraries that you need to install. So first of all, you need pandas, of course. Then you need numpy, of course. Okay,
Then you need scikit-learn. Basically, our machine learning models are in scikit-learn only, right? Most of them. Okay, scikit-learn is there. Then you have to add Flask also, because we will be making our web app too, right? Then we need joblib, right? Uh, joblib basically need to save models or anything in PKL formats, right? Then we need matplotlib and Seaborn also, so that you don't have to install them separately during your Jupyter Notebook testing. Okay, we will be doing visualization and all, right? So just list them there. Okay, so I think these are fine. If we need something else, we will later add them in your requirement.txt. Okay, just save it. Now create one more file in the root directory only. This will be your setup.py. Okay, you can copy any code for your setup.py. Okay, so let's open our GitHub, because I have my previous project also. So I will not be making setup.py again and again. If you want to know setup.py code in depth, just go to MLOPS project 1. Okay, that is your hotel prediction, right? Just go there and you will get everything in detail. I have told it line by line, right? So let's go to any project. Okay, go here. Let me open my repository and let's go to our fifth project only. Okay, so here is my setup.py file. You can copy from your any file. Okay, any project file. I have also given the code in the resource section also. You can just copy paste the same code, no worries. Okay, uh, just paste it here. Just change the project name. Let's name it 9. Okay, like this. Done. Okay, uh, setup.py is done. Now let's create one src directory. Okay, since src will be treated as a package, let's list a hyphen hyphen init hyphen hyphen dot py file. Okay, then inside src we need two files. First of all, our logger.py. Then in the src only we need our custom exception.py. And same thing, we will be doing the copy pasting work here also. So just go to your any project and in the src you will be getting this logger.py. Just copy it and paste it in the logger.py. Okay, and open your custom exception. Do the same with custom exception.py. Just copy your previous code, paste it here. Done. So your logger file and custom exception files are also done. Okay, and you already know the use of this init.py. Basically in the setup.py there are two things. First of all, packages installation. So it will find the packages. Okay, find packages mean it will check all the folders that have these init.py file. Okay, if a folder has this init.py, that folder will be treated as a package. Okay, it means you can import this logger.py from anywhere in this project. Okay, then it will also install our all the requirements. Okay, because it has already read the this requirement.txt, and all the requirements are stored in this requirements variable. Okay, and it will install these requirements. Done. Okay, so we will be making one training pipeline also. So let's create one folder. Let's name it pipeline, and pipeline will also be treated as a package. So let's list a init underscore underscore dot py. Okay, done. So you will be creating training pipeline here, right? uh, okay, so you need two more folders in the root directory only. Let's create templates. Okay, you will create your templates folder, right? Basically in the templates folder you will create your html files and make sure the name is correct. It should be templates only, because Flask automatically detects templates, right? It will automatically detect all your html files inside this template. It is by default feeded into the Flask system. Okay, but it will search for templates folder. Name should be correct. Make sure your name is correct. TEMPLATES, right? So you will be creating your HTML files inside this, and let's create one more folder, static. Basically, this folder is for creating your, if your website has any images, CSS files, JavaScript files, or anything. Okay, any external sources, anything. So those will be stored in static. Suppose if you want to show a video on your website, so you can store that video in static and then import from static to your index.html and like this. Okay. So with this, your project is setup is done. Let's install all the things. So for triggering your setup.py, you will write pip install -e full stop. Basically, it will trigger your setup.py. Press enter, and you can see it has started installing all the dependencies, and after that, it will start to install all the libraries also one by one. Okay, so with this, your project setup is done. In the next video, we will meet after this whole setup is done, and we will do our Jupyter Notebook testing. Okay, so let's meet at next video. Hello everyone. So in this video, we will be doing our Jupyter Notebook testing, and it is a very important video. Okay, so first of all, uh, okay, so let's create one notebook directory. So let's create one notebook directory. Inside notebook directory, let's create one ipynb file. So let's write notebook.ipynb. So this ipynb is the extension for your Jupyter notebook files, right? First of all, go to your extensions, VS Code extension. Make sure your Jupyter is installed. Okay, search for Jupyter and just install this. Okay. Okay, so basically it gives you Jupyter notebook support, right? Now just open a code cell and press shift and enter. Okay, so it will ask you to select a kernel source. So go with the Python environment, go with the recommended one. So it is your current virtual environment. So select it. Okay, so you can see now here it is VENV Python 3.1.2 something. Okay, just again go to any code cell, press again shift and enter like this. So it will ask you to install the IPY kernel package. Just install it. Okay, so you can see it has started installing your IPY kernel. Without IPY kernel, you can't write any code of Jupyter Notebook. Okay, so we have to install this IPY kernel. Okay, so let's give it time so that it can install IPY kernel successfully. After it has been successfully installed, we will start writing our Jupyter Notebook testing codes. Okay. Okay, so now you can see your Jupyter Notebook kernel, IPY kernel is successfully installed. Now let's start writing our code. First of all, let's see where our data is. Our data is in artifacts raw data.csv. Okay, remember this part. Let's go with imports. First of all, we need some imports. Okay, uh, first of all, our basic imports, import pandas as pd. Okay, then import numpy as np, then import matplotlib dot pyplot as plt, then import cborn as sns. Okay, and one more thing we can do, just write percentage matplotlib in line. Okay, so that your all the graphs are we can say in a good manner. Okay, so that they can be how I say that, basically your graphs will not spread out too much. Okay, they will be in a fixed shape. Okay, they will not leave the Jupyter kernel size. Okay, I hope you are understanding. Now we will import one more things, import warnings. Okay, and I will write warnings dot filter warnings, and I will write ignore. Okay, now what is this doing? This is a by default module in Python. And why we are writing warnings dot filter warnings ignore. You generally get some warning messages when you are working with Jupyter notebook testing. Okay, so it will ignore those messages so that your kernel will look clean. Okay, that's the only use of this. It's optional. You can write or you can not write. It will have no effect on your code. Okay, let's run it. So it is importing all the things. Okay. Okay, so you can see there is a tick here. Okay, you can see there is a success message. So you can move forward. Now we have to read our data. So we will read data using df equal to pd dot read csv. Our data is in artifacts raw. Okay, but currently we are in notebook directory. So we have to go outside this notebook directory. So you will write dot dot slash. Okay, now go inside artifacts. Now go inside raw. Now go to your data.csv. Okay, like this. Now you can check your data df.head. Okay, so it is your data. This data I have already told it is related to your smart industrial machines. Okay, these machines generally uses AI and something. Okay, and this is data is from your sensors. These machines have sensors. Okay, so this is your machine ID, operation mode, temperature, vibration, power consumption. Okay, like this. So first of all, let's check the shape. Df.shape. So you have around it's 1 lakh, right? So you have around 1 lakh rows and 13 columns. Okay, so you can see your columns here. Okay, now let's understand these columns one by one. Okay, because if you don't understand your data, you will not be able to make uh, any predictions on that type of data. You have to understand your problem before going through the solution of that problem, right? So first of all, first column is timestamp. Now what this timestamp is telling us, it is telling you the date. Okay, this is the date and this is the time. Okay, when that particular data was recorded. Okay, okay, whenever that every data was recorded, this is the date and time for that. Okay, then you have machine ID. Every machine is given a separate ID. Okay, just like you get separate roll numbers in your colleges or schools, same machines also get uh, unique IDs to distinguish between them. So this is a machine ID. So this machine has 39 ID, it has 43, it has 8, 29, like this. Then we have operation mode. Now let's check the operation mode. Let me copy this. Let's write df operation mode dot value counts. Wow. Copy, cut this dot value counts like this. So basically there are three operation mode: active, idle, maintenance. Now what are these three operation mode? Whether the certain machine is in active mode, it means it is running. Okay, when this data was recorded, that machine was running. Idle means uh, this machine is not running, it is in idle state. It is in a working condition, but it is not running. Okay, it is working but not running. Now we have maintenance. Maintenance means this machine is this machine can't be used. Okay, it is not in a working state. Okay, it is under maintenance. You can see 70,000 around machines are active. They are currently running. 20,000 were in idle state and around 10,000 machines were in maintenance condition. Okay, then we have temperature C. C means Celsius. Okay, so uh, it was temperature C determines your machine's operating temperature. Okay, when this data was recorded, what was the machine temperature? Okay, so it was around 74 degrees Celsius. Okay, machine was in idle state, and you can also distinguish uh, idle machines have a lower temperature because they are not working. If a machine is active, generally it will be producing more heat. Okay, if a machine is active, it will be producing more heat, and hence the temperature will rise. So you can see it has idle machine has 74, while active machine has 84. Okay, now you will be seeing you will be saying this machine is also active, but it only has a temperature of 44. But that also depend on the machine size, right? If a machine is small, obviously its heating properties will be far less as compared to the big machines. Okay, so that depend on the machine size also. Then we have another column, vibration hertz. Okay, this column determines the frequency of your machine vibration. Okay, basically this parameter is used to determine whether your machine is wear and tear. Okay, it helps you determine your machine wear and tear. If a frequency of a machine is too high, so it will go through wear and tear more fastly. Okay, then we have power consumption in kilowatts. KW means kilowatts. So it's basic column. Basically, it will be the power consumed by that certain machine. Okay, so it is around 8 kilowatts. Maybe it's a big machine, and it is a 2 kilowatt. So maybe it's a small machine, or maybe it was run for longer time. It was run for a smaller period of time, like that. Then we have network latency. MS means millisecond. Okay, so network latency means suppose this sensor recorded our data. Okay, that particular sensor on the machine recorded the data that you are seeing here, and it has to send that data from here to your server where this data was stored. So what was the network lag between sending that data? So that is your network latency. Okay, uh, then here it's your packet loss percentage. It is in percentage. Okay, 0.20 percentage, it means 20%. Right, it is 20%, right? Okay, 0.20% only. Okay. I thought it is in decimals. Okay, 0.20%. It is also telling when that data was sent from sensor to your server, what was the packet loss, okay, during the transmission. Basically, this feature will affect your real-time monitoring. If a packet loss is too high, okay, so data from sensor will reach the server in a very large time. Okay, so it can cause hindrance to our real-time monitoring. Then you have quality control defect rate percentage. It is also in percentage, 7%, 4%, 0.45%. Okay, uh, so it is the percentage of defective products. Okay, it is a percentage of defective product. Then you have production speeds unit per hour. Production speed unit per hour. So basically, these all machines are your manufacturing machines. Okay, these are your smart manufacturing industrial machines. Okay, that's why we are seeing the term production speed, because manufacturing means to produce something. Okay, so this production speeds unit per hour. How many units a particular machine is making in an hour? So it is making 477 units. It is making 398 units of products, whatever the product it is making. Then predictive maintenance score. It is a score. Uh, Basically, it is indicating a likelihood of a machine failure. Okay. Basically, it is telling you um, the higher the maintenance score, okay, the higher the chances of that machine failure. Okay. If a machine is requiring too much maintenance, okay, there are chances it can cause failures. Okay. So machines should be of less maintenance so that it will also do your cost cutting also. Then error rate. Okay, what is this error rate? Basically, it is the percentage of operational errors or failures that was detected by the sensors or machines. Okay, and at last, this is our output column. Okay, whether the machine is of low efficiency. Low efficiency means uh, it is taking more power, it is consuming your more money. Okay, in maintenance and everything, but it is not giving the desired output that you want. Okay, suppose it is taking too much electricity. Okay, it is producing average number of products. Okay, it is requiring high maintenance, so its efficiency is low because you have to invest more and you are getting profit less. Okay, then there is medium, then there are high. High means, let's check this efficiency status. We don't have any fourth option, right? Should be three only. Let's check. Okay, low, medium, high. So most of the machines are of low efficiency status, and some are of medium, and very less are of high. High means these machines require less electricity, less maintenance, but still giving us better results. Okay, although these machines will be costly, of course. Okay, you can also, I can also give you an example for this. Suppose let's take a refrigerator, or let's take a AC. Let's take one AC with 1 star rating. Okay, you get a 5 star. We can, that is, I think, efficiency rating only, right? 5 star AC, 3 star AC, 1 star AC, 2 star AC, like that. Okay, let's take one star AC, another 3 star AC, and last one a 5 star AC. So which will be the most efficient? Of course, 5 star AC, because it consumes less electricity and give you the same amount of coolness, right? 3 star AC, it consumes average amount of electricity and gives you good coolness. Then 1 star AC, it consumes high amount of electricity and give the same coolness as a 5 star and 3 star only. Okay, although the low efficiency machines are lower in cost, okay, as compared to the machines with higher efficiency. You can also see a 1 star AC cost too much less as compared to your 5 star AC, like that. Okay, so now you have understood, I think, all the columns of your data. Now let's proceed. First of all, let's check our all the columns. Okay, df dot columns. Okay, now I have to show you one more thing, df dot info. Okay, okay, info should have a bracket like this, and you can see here this timestamp is treated as an object. Okay, but it should not be treated as an object. It should be treated as a date time, because you have a data type date time also, right? So let's make our timestamp as date time instead of a object. Okay, so from here our basically data processing is starting. So let's name it data processing, like this. Okay, so what you will do basically, you will write df and just write timestamp, okay, equal to pd dot to date time. So it will convert this column to date time. Okay, in date time you will pass df timestamp. Okay, uh, and you can just write errors equal to codes. Okay, so if any errors are there, it will handle them during the conversion. Okay, now let's run it. Now let's check our df.info, and now you can see it is now in date time instead of object. Okay, so good for you. Okay, now it's done. Now let's move forward. Let's check for missing values first. Okay, df dot is null dot sum. Okay, it should be dot, like this. So you can see there is no null values here. Good for you. Df dot duplicated dot sum, there is no duplicate values also. Good for us. Okay, uh, we don't have any null values and duplicate values, so we don't have to drop them. Okay, so now let's convert the columns. Okay, Now let's convert the columns, basically categorical columns. You can see we have converted timestamp, right? But some of them are remaining, like your operation mode and your efficiency status. Okay, so let's name them uh, categorical columns equal to, let's take them from here only. Okay, so one is your operation mode, let's paste it here. Another one is your, what is another one, efficiency status. These are your categorical, sorry, object data types, so we have to convert them. Okay, like this. So these are your categorical columns. Now we will be converting them into category. Instead of object, they should be a category. Okay, because category is understood by machine learning. So what we will do, you will loop into these two columns for column in categorical columns. Basically, now you are changing the data types only. First of all, you change timestamp from object to data time format. Now you are changing these categorical columns from object to category format. Okay, you will see df call equal to df call dot as type, and inside as type you will write category. Run it, and if I run my df.info now, you will see it is in date time now. Your operation mode is now in category instead of object, and your efficiency status is also in category instead of object now. So that's good. Okay, so I think you have got the gist what we have done. First of all, we converted timestamp from object to datetime. Then we converted these categorical columns from object to category. Okay, so this was all your data type changing. Okay, let's do our EDA also. Should we do EDA here only? Let's do here only. Okay, let me create one markdown. Let me create one, sorry, EDA. Let's type EDA. Okay, let's do some visualization and all. So first of all, we will plot histograms for all the numeric features, because you can see most of them are numeric features. Okay, float. Okay, and one integer also. So let's plot histograms for all the numerical features, and column plot for efficiency status and all. Okay, now let's check. First of all, let's check all the numerical columns. So I will write numeric calls. Okay, so I will write df dot data types select data types include np dot number, like this, dot columns dot to list, like this. Okay, now you can see your numeric columns are what, just copy it, paste it inside this numeric columns. All the numerical columns are stored. All the numerical columns are stored. Okay, you can see there is no efficiency status, there is no operation mode, rest all of them are there. Okay, you can also check. I think length will be 11. Overall there are 13 columns, right? But it should be 10. Okay, I think we removed something. Okay, one is timestamp also. Timestamp is a date time format. Okay, so it will not be integer. So we have excluded timestamp and operation mode and efficiency status. So overall 13, but these three are excluded. So we have 10 numerical columns. Okay, now let's plot histograms for all these numerical columns. So I will write for, I will loop into each of the numeric columns for column in numeric columns, like this, and I will write plt dot figure. Let's pass the fixed size equal to, let's give it 5 comma 5 only. Okay, and Let's plot it using hist plot, SNS, using Seaborn hist plot. Okay, in hist plot you will pass your whatever the numerical column is, df call, and let's set kd also equal to true so that we can get our kernel density estimation also. And let's set the bins to 30. Okay, now let's give title plt dot title, and we will write title as f string histogram. It's histogram, not histogram. Histogram for df column, like this. Now let's show them plt dot show. Okay, let's press enter. Okay, so we are getting histogram for 0. What is this? Why we are getting this much? Mm, let's fix these using x label and y label also. It's not good in looking. So I will write plt dot x label. I will write here column, whatever the column name is there. Make sure the column name is there. Okay, on the x label. And plt dot y label should be your frequency, like this. And I think we should not name it df column. It should be only column. That's why we are getting this much. Okay, it should be column, histogram for the columns. I think now it should be good. Check. You can see now. Okay, histogram for machine id, not necessary. Machine id is a unique identifier, so we will remove machine id later. Okay, so we don't do in machine id. Yeah, you can see for temperature. Okay, so you can see the most of the machines have temperature. There is a uniform distribution for temperature. Okay, there is not much skewness in the data, so it's good. uh, for vibration also there is a very uniform distribution. Power consumption also uniform distribution. Network latency also uniform distribution. Packet loss also uniform distribution. Okay, quality control defect rate also uniform. It's too much uniform. Okay, error rate also uniform. Everything is uniform data distribution. Good for us, but I think this is a synthetic data. There's not this much uniform. This is too much uniform. Every column is uniform. Okay. Okay. Now let's make a pair plot. So I will write SNS dot pair plot, and I will write df numeric columns, like this, and I will pass plt dot subtitle. Okay, subtitle. Let's write it as pair plot for numeric features, like this. And after that I will write y equal to 1.02, like this, and I will show it plt dot show. Let's press enter. It will take some time to generate a pair plot for all the numerical columns. So basically it will show you the relationship between each numerical columns. That's it. Taking too much time, I think. Okay, so it has generated. Okay, so as you can see, all of them are uniform. Okay, all of them are equally spreaded, so most of them are uniform only. So I think it is a synthetic data. Okay, because there is too much uniformity. Okay, but no worries, we will deal with the data like this only. Suppose we get a real data also, so you can do the same processes, no worries. Okay, but there you will get a more better insights. Okay, because temperature, because you see, temperature and your this error rate, they have a uniform distribution with each other. Okay, so this may be a synthetic data, maybe not. It should be a synthetic data, it must be a synthetic data. only only then I think it will make sense, right? Now let's make some other graphs also for our categorical columns, then we will proceed with our feature engineering. Okay, that is a part of data processing only. Okay, now let's make a count plot for our basically efficiency status. Let's make it. I will write plt dot figure like this. Let's set the fixed size equal to 5,5. Okay, it's a decent size for Jupyter notebooks. I will write sns dot count plot like this. On the x-axis, I will pass my uh, efficiency status column like this. On the data, I will pass my df, and on the palette, I will pass. You can pass coolworm if you want. I will pass this time viridis like this, and I will write plt dot title. Okay, now you can give it any title. So I will write just efficiency status count plot like this. Okay, and x label, y label you can give. I am just showing you the graph plt dot show. Okay, so you can see most of the machines are of low status, sorry, low efficiency. Then around 25% of them are around medium, and very less, around 2000, 3000 are of high efficiency status. Okay, so we have already discussed that in during the our features introductions also. So I think there's not much EDA you can do, because this is a, I think, synthetic data. So there is not much EDA you can do, although it's a unique data. Okay, sensor data are very unique. Okay, so if you ever get a chance, work with sensor data, because those are real world data. Okay, generally machine learning engineers have to deal with sensors data only, right, to make their predictions. Now let's start with our data processing only, but it is our feature engineering now. Let's write FE. Let's do our feature engineering. First of all, what you will be doing from the timestamp, let me show your data. Tf.head. Okay, it is in markdown. Let me give a code cell. Okay, tf.head. Here's your timestamp column. Okay, so what we will be doing, we will be extracting this year separately, this month separately, this day separately, and this hour separately. Okay, so for this, what you will be doing, I will write df year. I will be forming a new column inside my data frame, and I will be extracting df timestamp dot dt dot r. Okay, like this. And let's do the same for month and date also, day also. Month equal to df timestamp dot dt dot month, because you can't work with the timestamp data directly. Okay, so you have to extract those features separately. You have, I think you have learned this during your feature engineering sessions from wherever you have learned. Okay, then we have our day, and we have df, then we have timestamp, then dot dt dot day. Okay, it will extract our day. Let's do the same for hour also. So let's, you can do the same for minutes and seconds also, but we are not going that much deep. Okay, hour is fine. Okay, timestamp dot dt dot r, like this. Let's run it. Now let's check our df.head. Let me run this cell again, and let's go at the last. You can see year 0, uh, month 1, day 1, hour 0. Why it's year 0? It should be 2024, right? Okay, I think there is a issue. Why it's taking year as 0? Okay, I have taken dt.r here in place of year. Okay. Now we have to run the cells again. Let's go to the top. Let's run these cells again. Let me read the data again. Okay. Uh, let me do the data processing again. Okay. I'm not doing the EDA. Okay. Now let's come to our, just go below. Now let's run it again. Okay. Now you will see df.head, and if you will see, now you are getting year 2024, month 1, day 1, hour 0. Okay, so now it is good. Okay, that time I placed hour here instead of year, that's why we were getting error. Okay, now you can drop this timestamp column if you want. Okay, you can just remove this if you want. Let's remove these. Let's remove df dot drop, okay, columns equal to, let's remove certain columns that we don't want. First of all, it will be timestamp because we have extracted the data that we need. Okay, so it will be our timestamp. Then it will be uh, machine ID. We don't need this machine ID. Let's copy it and paste it here. Okay, and rest we need. Okay, because machine ID is a unique identifier. So let's remove them and let's set here in place equal to true, so that it will make permanent changes. Let's run it. Now let's check the shape. It is 15. Okay, if you want to check, let's check df.head. Okay, now there is operation mode only. Your timestamp and machine ID have been removed successfully. Okay, so let's remove this. Okay, now what you will be doing basically, uh, let's go with, I think this much feature engineering is only required. Yeah, that's good, I think. Okay, so now let's start with our first of all, label encoding. Okay, we will label encode our efficiency status also. Okay, so I will write label encoder equal to, we'll initialize the label encode. Okay, we have to import it first of all. So I will write from sklearn dot, it is in pre-processing, right? Import label encoder, label encoder, like this. Now I will label encoder. Okay, I will write df efficiency status, or I can make a new column. Let's make a new column, efficiency target equal to label encoder dot fit transform. I will apply this fit transform on df efficiency status, and we will get a new column efficiency target. Let's apply it, and you can see I will write df dot head. Let's give only 2 columns. You can see at the end, efficiency status low, it means it is 1. So it has encoded low as 1. Okay, same, it has encoded high as 0 or medium as like this. Okay, you can check using this also, df efficiency status dot value counts. Okay, same way, df efficiency target dot value counts, like this. So you can see low is encoded as 1, medium is encoded as 2, and high is encoded as 0. Okay, got it. Now let's define our input variables and output variables. Okay, so what you will do, let's define our x equal to df. Let's define our input columns here first of all. I will write here features equal to like this. Okay, and I will write here df dot columns. After this, df dot columns. Okay, so these are our current columns. This efficiency target will be our output column, right? And these are all our input columns, not this efficiency status. Okay, this is the just the replica of your efficiency target only. So I want operation mode, temperature Celsius, vibration hertz, power consumption, network packet loss, quality control defect, production, maintenance score, error rate also. Okay, so these I want, just I will copy here. Okay, after that I don't want this efficiency status, I want this year, month, day and hour. So just copy them and paste them here. So these are your all the features. So I will pass x means your input features. So in input features, all of your these features will be there. Okay, so you can check your x dot columns. Okay, so the above features are there. Okay, which you defined in the features, only those features are in the input feature. Okay, in the same way, let's define our y will be our df efficiency target. Okay, so you have your input columns now and output columns now. Let's scale them. I will import from sklearn dot preprocessing import standard scaler. Okay, let me initialize my scaler equal to standard scaler, and I will write x scaled. I am performing scaling on this x. Okay, I am writing scaler dot fit transform like this. Fit transform x. Okay, so it has done, could not convert string to float. Okay, so I think it is related to your operation mode, right? Okay, so we have to encode our operation mode also, I think. So let's encode our operation mode also. Just copy it, paste it, and I will write here operation mode this, and I will write operation mode. Let's run it. Now our operation mode is also encoded. Now it should work. Okay. Mm, I don't know why it's not working. Let me check my df.head. Okay, operation mode is there, everything is there. What it's showing basically, okay, could not convert string to float. Could not convert string to float. Okay, let me fix this issue. Okay, so we were getting this error. Let's remove this standard scalar for now. Okay, let's remove this. Okay, and if I check my x dot columns, sorry, x dot head like this. Okay, so it was causing issue because we have changed it in, we have label encoded this df, but we have not encoded it in x, right? So I have to encode it again. Just run your features again. Okay, x features again, y again, now scalar, and now you will see it has been encoded. Okay, the problem is that I have encoded them in df, but they were not encoded in x, and scalar was working on this operation, is on x. Okay, so now let's do the same scalar, standard scalar. Now if you will write x scaled equal to scalar dot fit transform, and just apply on x. Okay, run it. Now you can see it has successfully run. So for now, input columns are in x scaled, output is in y. Okay, so you have done the scaling now. Okay, so now let's split our data into train test split. So I will write from sklearn dot model selection import train test split. Okay, so I'm writing x train, then I want x test, y train, comma y test, like this. I'm doing train test split. I will be splitting my x scaled. Okay, I will be splitting my x scaled, that is your input data. Output data is in y. Okay, test size, let's take it 0.2. Okay, and let's give a random state of 42, like this. Okay, and give a stratify equal to y. Let's run it. Okay, so now your data have been splitted successfully into xtrain, xtest, ytrain, ytest, of which xtrain and ytrain will be used for your training your model. Xtest will be used for making the prediction from the model, and then we will compare that prediction with our ytest, that is the actual values. Okay. Okay, so which machine learning model should we take? You can do your model selection, train each model, which we have done in project 1, project 2, like that. But I will be taking very simple model, that is our logistic regression, because first of all, it is a very synthetic data. Okay, all our data is very uniform. Okay, so for the uniform data, logistic regression works pretty good. Okay, and since we will be deploying this in our VM instances later. Okay, that is the most important part of this project. Okay, so I think we should take a project that has a smaller model, faster model, so that we can work easily, because GCP provides you only a limited amount of storage and processing power. So let's go with logistic regression only. So I will write from sklearn dot linear model import logistic regression. Okay, let's initialize our logistic regression. CLF equal to logistic regression, and let's give it a random state of 42 only. Okay, max iteration, let's give it by default value, that is 1000. Okay, and let's CLF dot fit, let's train our model on x train and y train. Okay, so our model is trained because it is fast. Okay, now let's make our predictions. Y prep equal to model, sorry, model is CLF dot predict on X test. We are making prediction on X test and storing those prediction in Ypred. Okay, so we Ypred have our prediction now. Okay, let's calculate the accuracy from sklearn dot metrics import accuracy score. During our model training phase and model evaluation phase, I will import more metrics like your recall, precision, F1. But for now, let's go with accuracy score since it is our Jupyter notebook testing. Okay, so I will write accuracy score. You will pass your Y test, that is your actual value, and now your Ypred, that are your predicted value. So it will compare them. Okay, so it is giving us 0.91. It means 91% accuracy. That is a very good accuracy. Uh, since we are using logistic regression, suppose if you have used a higher model like XGBoost, Gradient Boost, a random forest, so you have easily got around 98, 97 easily. Okay, and suppose if you have hyper tuned the logistic regression also, you will get around 93, 94 easily. Okay, and you can do one more thing. Let's in the metrics only, let me import a classification report. Okay, let's print a classification report also. Same, pass your Y test and your Y pred. Okay, okay, it should be in print classification report. Okay, so your precision is around 0.85 for your 0th class. Okay, so 0th I think is denoted by high. Okay, high efficiency machines. Okay, so F1 around 0.849578. You can see all these. Okay, so pretty much good. Precision, recall, F1 score, accuracy, everything is pretty much good. Okay, and we can't make ROC AUC score. Okay, because this is not a binary classification. We have 3 classes. Okay, so you can't do ROC AUC here, right? Okay, what you can do basically, uh, we can do one more thing that is called permutation importance. Permutation importance. Okay, I will tell you what is this. Basically, it will tell you the importance of the features. Okay, like just you get in random forest inbuilt feature importance, XGBoost inbuilt feature importance. Same here also, but you have to import something. First of all, you have to import this permutation importance. So from it is in from sklearn dot inspection. Okay, import permutation importance. So you have to import it. Okay, let's run it. Now you are ready to go with your permutation importance. Okay, so for this you will write the code. You will write result equal to uh, permutation importance. Okay, you will use your permutation importance. First of all, you will pass your model here. Model is your CLF, then your X test and Y test. So it is your X test and your Y test. Okay, then number of repeats you have to pass. Number of repeats, let's set it 10. Let's give it a random state of 42 only. Okay, and number of job you can set it -1 and jobs equal to -1. Okay, like this it is your result. Okay, so it will basically calculate your result. Let's check what is this inside this result. Okay, so these all things are inside the results. Importance, mean, importance, standard deviation, importance is arrays, like this. Okay, now you will see how we will make it in a graphical way, or we can in a pandas data frame way. Okay, for this you will write, let's make a importance df equal to, I will create one pandas data frame. Pandas data frame. Okay, inside pandas data frame I will create one column feature. Okay, feature will be my features only, okay, which we have defined above. Okay, all the features that we are taking, these features, okay, I have defined them above only. And my importances will be you will write result dot importances mean. Okay, so mean you will be accessing this. Okay, importance, I think I have written the wrong spelling. Let me copy from here and paste it here. Okay, like this. Okay, so now you have importances df. Let's check this importances df. Okay, so this is your operation mode, these are your these, this is your this. So what you can do, you can just sort the values. Okay, what you can do, importances df dot sort value, so that you can get the top value above. Sort values by import. Okay, you have to pass this column name, copy it and paste it here, and we will set ascending equal to false. Okay, okay, so you can see this error rate percentage is the most important feature. Okay, it has a 0.23 contribution. Then you have production speed 0.117, then network latency, and the least important is month. Okay, and these are very least important. You can remove these if you want, it will not remove. Okay, if you want, you can just go with these top 5 also. Okay, then also you will get the 91% accuracy only, right? Okay, okay, so with this your Jupyter notebook testing is done. Now you can, what changes you can make, you can use more advanced models. Okay, you can use other data sensors. Okay, you can use other sensor data. Okay, Kaggle have a very wide variety. Okay, you can just go with any sensor data and just implement your own logics and all. Okay, you know, machine learning, basic machine learning, and MLOps I am teaching you. Basically I am teaching you technologies of MLOps that are used in production. Okay, right? So you can do one more thing, you can do hyperparameter tuning here in the data set to increase your model accuracy, right? Okay, so with this your Jupyter notebook testing is done. I think it was a very easy Jupyter notebook testing, okay, as compared to your MLOps project 2, that was for anime recommender system. Okay, so because our main focus of this project is not to learn a complicated project. Okay, our main focus is to learn advanced complicated technologies that I will be telling in the upcoming videos, where we will be creating our VM instance, configuring them, everything. Okay, it will be very complicated, I'm telling you. Okay, now let's jump to our next video, that is our data processing, where we will be using the same things that we did in our Jupyter notebook testing, but just changing the approach. In the data processing video, we will be using classes, objects, a more modular way. Okay, so let's jump into it. So hello everyone. So I hope you have done your Jupyter Notebook testing successfully. In this video, we will be doing our data processing, which is inspired from our Jupyter Notebook only. So do that. Just open your SRC. Okay. In the SRC, let's create one file, data processing.py. Okay. So in this file, we will be doing all the data processing work. Okay. So first of all, let's do some import. We want our pandas, import pandas as pd. Then we want our numpy. Okay, so import numpy as np. Then we want our job lib for saving the pkl files and all. Okay, and then we want label encoder and scaler also, right? So from sklearn dot preprocessing import label encoder and standard scaler. We have used them in Jupyter notebook testing, right? Okay. and we have to split our data also. Okay, so from sklearn dot model selection import train test split, right? Then we have to import our logging and custom exception file. So from src.logger import get logger, and from src.custom_exception import custom exception class. Okay, now we have to initialize our logger. So I will write logger equal to get logger and our name magic method. So our logger is initialized with the name logger. Okay, now let's create our data processing class. So let's create class. Let's name it data processing. Let's define its constructor init, and first of all universal parameter self. Then we will pass our input path and output path. Input path, from where we have to take the data. We have to take data from artifacts raw data.csv. Output path means after all the data processing is done, we will get four things: our xtrain, ytrain, xtest, and ytest. Okay, four things. We will save these four things, and we will also get our scalar. Okay, we will get five things. We will save these five things in our uh, artifacts process directory. We will create one new directory inside artifacts that is processed, and inside that process we will save our all these five things. Okay, so input path is your artifacts raw, and output path is your uh, processed. Okay, okay, one more thing we have to import. We have to import our OS library. Okay, for creating our directories and all, we need our OS library, of course. Okay, got it this much? Now, in the init, let's define some instance variable. First of all, self dot input path equal to input path. Okay, and same for output path also. Self dot output path equal to output path. Right. Now, what you can do next is self dot df. Okay. Currently, it will be none, but later we will store our uh, data frame here, because currently it is in data.csv. It is in CSV file. We will read it and store it inside self.df. Okay. Then we have self.features. Okay. You know, we in Jupyter Notebook testing, uh, we have selected some features after all the things. So we will store all those features in self.features. Right. Sorry. Okay. So done till here, and we will do one more thing. I will write os dot make directories self dot output path and exist okay equal to true. Okay, so it will check whether this output path, in our case it will be process directory, it exists or not. If it doesn't exist, it will create one. If it exists already, it will skip this part. Okay. Sorry. Okay, so this much is done. So this was your constructor. Now let's create our first method, that will be load data. So basically we will load our data. So let's pass self here only, and we will make a try except block. Okay, and okay, we can do one more thing. After creating all the constructor, I will write logger dot info data processing initialized. Okay, so it means data processing have been initialized. So after try block in the load data, I will read my data. Okay, I will read my data inside self.df. Currently self.df is none. After we have read, it will store our data. Okay, I will write pd dot read csv, and we have to read the data from our input path. So I will read from self dot input like this. Okay, and you can just log the information logger dot info. You can just write data loaded successfully like this. Okay, now coming to the exception part, I will write except except exception as e. We will log this error also. So I will write logger dot error, and let's give a string. error while loading data, and let's show this error also. Same way we will raise the custom exception also. So I will raise my custom exception, and let's name it, you can name it anything like failed to load data, like this, and we will show our custom exception here also. Okay, so your first method is made. Basically here you will be loading your data. So now you have read your data.csv, and your data.csv is in data frame format inside this self.df. Okay, now we have to do data processing. Okay, so let's create one more method. Let's name it pre-process, right? Let's give it self. Of course, we will make one track set block. Okay, and let me open notebook for reference. Okay, so what we have done in data processing, let me go above. Okay, so we have read our data here, and okay, so first of all, we transformed our data, sorry, timestamp column from object to date time format. So we will be doing the same thing. Let me copy this here and paste it here. And instead of df, I will write self.df. Okay, same for here also, self.df. Okay. Now next, what you have done, you created all the categorical, sorry, you transformed categorical column also from object to category. So let me copy this and let me paste it here. You have to fix the indentation, make sure. So let me do it like this. Okay, like this. Okay. Instead of df, you will write self.df, here also self.df, like this. Okay, so you have done this data processing. Now what you have done after that, it was eda part, so let's skip the eda part. Okay, also we didn't get much insights from the eda part, but if you want to learn eda in detailed, okay, so make sure you visit my project 1 and project 2. I think that is hybrid anime recommender and hotel reservation. There I have explained in detail. Okay, here all the things are uniform only, so that's not much we can do, right? So yeah, our feature engineering started from here, so let's copy this much. Okay, so it will also come inside data processing only. Okay, so let's fix the indentation. Let's fix the indentation, and instead of df, I will write self.df, and here also self.df, here also self.df, here also self.df, like this. Okay, and same way I will write self.df, here also self.df, here also self.df, here also self.df, right? Done this much. Okay, now after that, what you have done, you have removed these two columns. Okay, so let me copy this and paste it here, and just change the name. I will write self.df. Okay, so you have to just follow the notebook and just make some minor changes, and everything will get changed. Okay, now what you have done next, you have basically encoded your efficiency target and sorry, efficiency status and operation mode. Okay, you have encoded two things. Okay, so what I will do basically, uh, let's make a little change. I will write columns to encode. I will list the columns that I want to encode here. Okay, so my first column is this efficiency status, right? So let's copy this, paste in data processing. Then our second column is operation mode, right? So let's copy this and paste it here. Okay, so these will be the columns that we want to encode. Now let's initialize our label encoder. So let's initialize with the name le and label encoder, like this. Okay, good, good. Now what you have to do basically, I will loop into this columns to encode. I will write for, okay, I have to do it here only, right? For column to, for column in columns to encode, I will loop into each of them efficiency status and operation mode. I will write, I will initialize separate encoders for both of them, okay, so that I don't have to write these two again, okay, I don't have to write label encoder again and again, okay, it will be done in one. I will write, you can just copy this, you can just copy this, okay, just copy this much, copy it, paste it here. Instead of df, you will write self.df. Instead of efficiency target, you will pass your column here, of course, and instead of label encoder, you will give the name that is le, okay, and same here it will be self.df, and it will be your column, okay, done. So you have done your label encoding also. Now what you have to do next, I don't think we have to do next. We will just make another method for splitting and scaling our data, okay, so let's keep it here only. So I will just do a logging, logger.info, all basic data pre-processing done, like this, okay, and for exception you can just copy this and we will change the syntax, oh sorry, yeah, syntax, and just change error while pre-processing data, pre-processing data, it's not syntax, it's message, okay, fail to pre-process data, like this, okay, so your second method is also made. Now let's create our third method, that will be split and scale, okay, split and scale, like this, okay, let's pass the self here only, okay, of course track set block will come. Now what you have done basically, okay, so these were your features, right, these were your features, uh, okay, so let me copy these, copy it, paste it here, okay, let's fix the indentation a little bit, like this, and instead of features I will write here self dot features, okay, because we have defined one instance variable above, right? So with this, our these will be our input variables, sorry, input features. Then I will define my x, so I will define it here, okay, I will write self dot tf features, and I will write self dot features, okay, and same goes with the y also, just paste it here, and let's write self.df, but this time it will not be efficiency target, it will be efficiency status only, okay, because we have not changed the name, okay, so it should be efficiency status. I think s is capital, right? Okay, so s is capital, yeah, good. So we have our x and y now, okay, we have to scale them, okay, we have to scale them. I can write this name split and split and scale and save also, okay, we will save here also, let's not make another method for saving, let's save it here, okay, split and scale and save, like this. So we have splitted our data into input and output feature. Next what you will do, you will scale your data. So let's initialize our scalar like this, okay, let's initialize our scalar like this, scalar equal to standard scalar, x scale equal to scalar dot fit transform x, like this, nothing will change. Then let's copy this, we have to split our data, x train x test, y train y test, train test split, x scaled, y test size stratify y. Okay, pretty much fine. Okay, now you have splitted your data. You have got your data also. Now just save them. You have to save them. You have to save your xtrain, xtest, ytrain, ytest, and your scalar also. So now let's start saving. For saving, we will use joblib.dump. I am not getting joblib.dump. Okay. Have I made any error? Why joblib is not working? It should suggest me dump, right? But it's not suggesting. What can be the issue? I don't know. Let's check. Let's write it for now. If we get any error, I will tell you. Okay. So here you will pass xstring. Okay. And you have to pass the path where you want to save it. So I will write os dot path dot join. Okay. Firstly, we will go inside our self dot output path. Okay. Whatever we have defined the output path, we will define process directory basically. So I will go inside my self dot output path. That is your process directory. After you have got inside this output path, process directory means I will save it by the name x train dot pkl. Okay, it should be underscore. Okay, like this. So I will do the same for our all the other forts also. Paste it, paste it, paste it. Okay, so it is x train. Now it will be x test. It will be y train, and it should be y test, like this. Okay, and let's change the file names also. Xtrain, xtest, and let's name it ytrain, and let's name it ytest. Simple enough. Now let's the save in the same way. Let's save the scalar also. So I will write joblib.dump. I will save my scalar. Okay, and I will save it with the same thing, os.path.join. Let me copy this much, paste it, and let me create one bracket here. And instead of this, I will give it a name scalar.pkl. Okay, you can make a more advanced data processing file also. You can use your config, YAML files, everything, which I have already told in project 1 and project 2. There I have discussed mainly on the project part, but now we are focusing on the technology part mainly. Okay, so that's why project is simple. Technology will be difficult. You will see that in the upcoming videos. Okay. Okay, so we have saved. Now just do the logging, logger.info. All things saved successfully. You can give your own message. Okay, for data processing, like this. Okay, and let's do the exception handling. So I will just copy the previous exceptions, copy it, and paste it here. Okay, I can write error while split, scale, and save, right? Same here, fail to split, scale, and save. Okay, now I will create one more method. This method will be run method. Basically here I will combine my all the three methods that I have mentioned above. So I will write self dot load data. First of all, it will take place. Then self dot pre-process will take place. After that, self dot split and scale and save, it will take place. So that I don't have to run these three methods again and again. I will just run dot run method one time, and all these three will get executed. Okay, done. So this was all your data processing. Let me give you a summary. First of all, we done some basic imports, initialized our logger. Then we make the constructor for our data processing. Then we made a load data method. Then we made a pre-process method. Then we made a split, scale, and save method. Okay, that's why our joblib.dump was not working. Here, instead of colon, I have made a semicolon. Now joblib.dump will work. Okay, that's why we were not getting suggestion for joblib.dump. Okay. Let's check now. We were getting, still we are not getting. Let's check if you face any error. Maybe it is a problem with VS Code only. Let's check. Okay, now let's, for checking, I will write if name equal to main. It means someone, if someone run this file, whatever you write inside this block will get executed. Okay, so I will just define my data processing class. So I will make a processor object of data processing class. Now data processing class asks for two things: your input path and output path. So our input path will be artifacts raw data dot csv, right? And our output path will be artifacts processed, like this. And I will just write processor dot run. I don't have to write processor dot load data, processor dot preprocess, processor dot split and scale. I will just write processor dot run, and all these three will get executed at once. Okay, let's save it. Let's check. So I will just open my terminal. Make sure your virtual environment is activated. I will clear the screen. I will write Python. Go inside src. Go to your data processing dot py. Yes, enter. Hope so it works. It should not give any error. Okay. We are not getting any logs now. Let's wait. Okay, let's see. Okay, so I think it has successfully done the data processing. Okay, all things saved successfully. Okay, so it was a VS Code error for not suggesting us in joblib.dump. Okay, okay, let's check our artifacts. We have our scalar extest xstring. Let me open this in file explorer so that we can check whether these are not corrupted or not. So I will open my processed, and you can see they are of significant size. Okay, xtrain is 2 MB, 0.6, 8 MB, 2 MB, and it is 2 KB scalar hour. Okay, so it means they are not corrupted. If they were of 0 KB, it means they were corrupted. Okay, there are chances they were corrupted. Okay, but in our case, they are perfectly fine. Okay, so good for us. So with this, you have done your data processing successfully. Now, with in the next video, you will be doing your model training, as well as you will be making your training pipeline also. Okay, so let's go to the next video now. Hello everyone. So I hope you have done your data processing in the previous video. In this video, we will be doing our model training as well as our training pipeline. Training pipeline is simple only. Okay, so first of all, just go to your src and let's create one more file here. Let's name it model training. Okay, if you want, you can create different files for model training as well as model evaluation also, but we will be doing in the same file. Okay, model training.py. Okay, now let's do some basic import. We want our OS library, of course. Okay, but I'm writing import OS, and then we want our job lib because we want to load all the training, sorry, all the these xtrain, ytrain, xtest, ytest. If you want, you can use your feature stores also. Okay, release or feast, which I have already told in the project 3, I think. Okay, so you can just go there, then you don't have to save like this. Okay, then you have imported job lib, then you want your pandas spd. Okay, then we will be using our logistic regression. So for that, I will write from sklearn dot linear model import logistics regression. Okay, then we want our logger. Okay, and same way we want our custom exception also. Do we want anything else? Okay, metrics from sklearn. Okay, sorry, sklearn dot metrics, I will import accuracy score. I told you in the Jupyter notebook testing, we will import more metrics here. So I will write recall score, precision score, and F1 score also. You can also do the confusion metric classification report also if you want, but let's take 4 for now. Sorry. Now let's initialize our logger equal to get logger name. Okay, if we want some more imports, we will import them later. Okay, don't worry. Let's make a model training class. I will make my model training. Let's define its constructor. So I will write def init. Okay, so first of all our self will be there, then process data path. Okay, basically it will be our process directory from where we will access our xtrain, ytrain, xscaler, everything. Okay, and other one will be our model output path where we will be saving our model. Okay, we will be creating one more directory inside artifacts, our models directory, so that we can save our models. Okay, okay, now let's make the initial instance variable for them. Self dot processed path equal to process data path, and self dot model path equal to model output path, like this. Okay, and self dot clf. Okay, so it will be our classifier. Okay, self dot clf will be our model. Okay, by default it will be none. We will later add the model inside this self dot clf. Okay, after that what you will be doing, uh, let's define some instance variable for these also. Xtrain, ytrain, xtest, ytest. Okay, so I will write self dot xtrain and self dot xtest, comma self dot ytrain. Sorry, y should be small, and self dot ytest, and these all will be by default none. So I will write none, comma none, comma none, comma none. So these all four will be none by default. Okay. So now let's create our directory os dot make directories for our self dot model path, comma exist okay equal to true. Okay, if the model directory already exists for storing the model, then it's good. If it doesn't exist, please make that directory. Okay, so first of all, let's make our new first method, that is our load data. Basically, we will load our data here. So I will write self. Let's make inside try block. Okay, you can do one more thing here. Just do the logging logger.info. I will just write model training initialized, like this. Okay, so inside try block, first of all, you have to load your all the things xtrain, xtest, ytrain, ytest. Okay, so I will write self dot xtrain. I will load it inside self dot xtrain. I will write job lib dot load. Okay, uh, you have to pass the path where you have that file. So I will write os dot path dot join. Okay, os dot path dot join self dot processed path. Okay, whatever our processed path you have passed, it means the process directory. Inside that process directory, okay, you have to go inside, and our file name is xtrain.pkl, and you have to fetch that file. Okay, and then do the same for other forts also. Control C, and let's create another 4 times, and next time it will be x test, then it will be y train, and after that it will be y test, like this. You have to change the name here also. Let's make it x test, and let's make it y train. Let's make it y test. Make sure your name matches with the here. You can see on the left pane. Make sure your name matches. Okay, so you have now loaded them. You can just do logging logger dot info data loaded successfully, like this. Just do the custom exception handling, except exception as e. You will just try it. You will just log the error, logger dot error, and just give it inside the f string error while loading data, and just show that error. Okay, and now simply raise the custom exception also, like this. Failed to, sorry, failed to load data, like this, and just pass the exception here. Okay, good. So you have made your first method for loading your data. Okay, now our next method will be, since we have our data, now let's train our model. Okay, let's train our model. Let's pass the self here, and we will save also. Okay, we will not just train, we will save also here only using job lib, of course. Okay, so I will initialize my model inside self.clf, which we have stated in this constructor. Okay, self.clf. So I will pass my logistic regression, of course. Let's give it some parameters like your random state. Let's keep it 42, and max iteration 1000, that is the by default value. Okay, so you have defined your logistic regression. Now you will write self.clf dot fit. You have to fit that data on, you have to fit in on xtrain and ytrain. So I will write self dot xtrain and self dot ytrain. Okay, now your model will start training, right? Now you have to save that model. So for saving, you will write simply joblib.dump. Okay, I have to save this clf dot self dot clf. Okay, now where I want to save it, now you will pass after comma the path. So I will write os dot path dot join. Okay, what was the path I defined? Self dot model path. Okay, this self dot model path. This self dot model path is your models directory, artifacts inside artifact models directory. Now inside self dot model path, what you want to name your model? I want to name it model dot pkl. Okay, like this, it will save your model also. Okay, you can just do now logging logger dot info. You can just write model trained and saved successfully, like this. Okay, and just for exception handling, just copy the previous one. Okay, and just paste it here. Okay, error while training model. Let's slide error while train sorry error while training model, fail to train model, like this. Okay, simple. This is very simple project. If I compare it with the anime recommendation system, that was quite the hectic project. Okay, but it was fun too, right? In the project too, it was fun. Although in this project, you are not having fun in these part, your Jupyter notebook testing, model training, but you will have fun in the upcoming videos when you will be configuring your VS instance. That will be very tough part. Okay, so make sure watch those videos very carefully. Okay, I have already told in the introduction, those videos will be tough. You have to have a very mm, high level of concentration and patience. Okay, now let's evaluate our model also. Let's create one more method, evaluate our model. Let's pass the self here only. Okay, tracks at block, of course. Okay, now what you will do basically, you will predict using your self.clf dot predict. Okay, on which you will predict your self x test. and you will compare it with your self.y test, this y thread. Okay. First of all, let's go with accuracy. Accuracy equal to accuracy score, and you will compare your self.y test with your y thread. Okay. Same with the precision also, equal to precision score, same self dot uh, y test comma y pred. But since it is a multi-class classification, you will pass one more thing here, that will be average equal to weighted. Okay, so let me copy this for recall and f1 score also, paste it. Okay, for precision I will write here recall, and instead of precision score I will write here recall score. Okay, same here also, instead of precision score I will write f1 score, and here also I will write f1. Okay, so you have your accuracy score stored inside this accuracy variable, precision score precision variable, recall score recall variable, f1 score f1 variable, like this. Okay, now let's log these all the things, all the metrics into our logging. So I will write logger dot info. I can just write f accuracy. I will just write here accuracy. Okay, just do the same for others also. Logger dot info f string precision score equal to precision. Now let's do for the recall. Logger dot info f string recall score recall, like this. And let's do the same for our f1 score also. Logger dot info f f1 score. Okay, f1, like this. If you want to do your experiment tracking, you can also do that. I have told you many ways to do experiment tracking. You can do with MLflow, you can do with MLflow DAGs Hub, you can do with Comet ML, you can do with TensorBoard. I have told you many ways. Okay, so I'm not telling experiment tracking in this step. In the previous projects we have already done. Okay, now uh, you can either also create classification report, confusion metrics, but let's keep it simple for this project. Okay, because later you have to deal with tough parts already. Okay, so now let's log the message logger.info. I can just, sorry, there are two dots. I will just write logger.info model evaluation done, like this. Okay, and I will just write except exception as e. Okay, and I will just write logger dot error, and I will just show the error while evaluating model. Okay, like this. And just raise your custom exception also. You might be wondering why didn't I copy it this time. I forgot already. Okay, so I have right here. Okay, fail to evaluate model, fail to evaluate model comma e, like this. Now let's create one more method, that is, you already know, your run method, so that you can compile all your method at once. So first of all, first one was our self dot load data, then was our self dot train model, then was our self dot this evaluate model, right? Let's give you a summary. First of all, we done some basic imports. Okay, we don't need pandas. I think we have not used pandas here, so you can just remove the pandas if you want. Okay, basic imports. Then initialize your logger, created the model training class, defined its constructor. Okay, loaded our all the things from our processed directory that we have already done during data processing. Okay, then trained our model, saved our model here only. Okay, and then evaluated our model. from basic metrics only, accuracy, precision, recall, F1, and then compiled our all steps into one. Now let's check whether it's working or not, whether it's not showing us any error. Let's check it. If someone run this file, whatever you have written in below this will get executed. So let's define object for our model training class. Model training asks for two things, right? It asks for process data path, it means your process directory, model output path where you want to save the model. So first of all, processed path, you will pass artifacts processed, okay. And for your model output path, I will pass artifacts and models, okay. So inside artifacts models, your model.pkl will be stored. Now I will just write trainer.run, okay, because our run already has compiled all these three methods. Now I have to run this. So for this, I will just write Python, open your terminal, make sure your virtual environment is activated, src model training.py, okay, press enter. Hope so it works, please works. Okay, so, okay, we are getting models and we are getting our model. Let me check. Model not corrupted, right? It is of 2 KB, but it was a small model. We have used logistic regression only with very less hyperparameter tuning. Let me check the logs, and you can see model evaluation successfully done. So it means our model has been trained successfully. Okay, so we have done this much. Now what we will be doing, now we will be creating our training pipeline. So for training pipeline, go inside your pipeline directory, create one file here, training pipeline.py. Okay, you don't have to do much here. Okay, just how many components do you have in this project? We have only two, data processing and model training. Okay, just go to your data processing and copy this last thing. Okay, just copy it, paste it in the training pipeline. Okay, go to the model training, paste this last thing. Okay, just copy it and paste it below this. Okay, now you can see there are some import errors. Let's fix them. Basically we have to import data processing class, so I will write from src dot data processing import your data processing class. From src model training class import your model training class. Okay, done. So now let me delete these logs so that we can get fresh logs. Now I will write just Python, go inside the pipeline now, pipeline directory, inside pipeline, training pipeline.py. Press enter and you will see your new logs. Okay, okay, done. You can see your new logs. Data processing has done and model evaluation, all the things were done. Okay, so you don't have to run data processing separately, model training separately to achieve the same things. You just have to run training pipeline.py and all the things will get executed. Okay, but this was very basic way of making a training pipeline. Generally, you can use your DVC to make custom training pipelines. Okay, I have already told how to make custom training pipelines using DVC in, I think, project 4, right? I don't remember, but it is, I think, in the custom object detection project, right? So you can just go there and copy that training pipeline part here also. You can implement that here also. Okay, just follow the same steps from that project 4. Okay, so with this, your model training is done, your training pipeline has been made. Now only thing remaining is you have to make your user app building. Okay, and after that our main part will start. That is, first of all, basically after user app building, you will go inside your main part, that is your CI/CD part basically. Okay, where you will be doing continuous integration deployment using a Jenkins, ArgoCD. Basically, your GitOps deployment will start. Okay, so that will be the fun part. Okay, so just let's proceed with the user app building fast, and let's finish user app building, and then we will move to the interesting part of this project. Okay, so let's go. Hello everyone. So I hope you have done till your model training and training pipeline. In this video, you will be making your user app using Flask, and we will be using AI over ChatGPT. If you want, you can use DeepSeek also. Okay. Okay. So first of all, in the root directory, you will create one application.py. Application.py. Okay. Let's import some things. First of all, sorry, from Flask, import Flask, and then we import render template. Okay, then we want import joblib for loading our model and scalar, right? Then we want numpy as np. Okay, then we want our os library also. If you want, let's not import os for now. Okay, let's initialize our Flask app equal to Flask and name. Okay, so your app have been initialized. Now whatever you write inside this will be inside your Flask app logic. Okay, so first of all, let's give our model path, and let's give our scalar path. Okay, so our model path is artifacts. Inside artifacts models. Okay, let me check models. Inside model.pkl. Okay, model.pkl. Okay, same you can give the scalar artifacts processed and scalar.pkl, right? Let me check, and scalar.pkl. Okay, so now let's load these. I will load it here. Model equal to joblib dot load from this model path, and our scalar equal to joblib dot load from this scalar path. Make sure in whatever library you are using for saving, make sure you load it from the same library. If you are saving using pickle and loading using joblib, it will not work. Okay, if you are saving using pickle, load also using pickle library. If you are saving using joblib, load also using joblib. Okay, because their encoding methods are different, right? I will prefer joblib anytime over pickle. Okay, although pickle is inbuilt installed in Python, right? Now let me define a variable features. Okay, so basically here I will list my all the features. Here I will list my all the input features basically. Okay, so where you will get this, just why I'm listing it, you will get to know about in just a minute. Let me open my data processing for now, and I have one this. Okay, so let me copy this. Okay, these were our input features, right? Because we created input features from here, so I don't have to write it again and again. So just paste it here. Okay, so these are your all the features. Done. Now you have to give labels also, your output labels basically. So let's give it in a dictionary format. So basically there will be three labels. One will be 0. Okay, one will be 1. Okay, and one will be 2, right? You have to check 0 is defined by which and 1 is defined by which. Okay, so for this what you can do, just go to here in the label encoding section where you have done your label encodings. Okay, you can just write here the code to show the encodings also. Okay, it generally encoding is shown using le dot classes underscore. Okay, but now for now, why to make changes in the code, let's take the example from our notebook, and you can see, let me open the notebook. Let me open the notebook in the separate tab. Close this, and you can see, okay, low was defined by 1, and 2 was defined by medium, 0 was defined by high. Okay, so 0 means high. Okay, you can give any name if you want. Okay, 1 was defined by low, right? And 2 was defined by medium. This was there, right? Yeah, so I think the same encodings were here also. Okay, So these are your labels, because otherwise the output will, when you make the prediction, it will show 0, 1, 2. How you know what refers to 0, what refers to 1, what refers to 2? That's why we are making labels. Okay, so we have made labels and features. Okay, now let's make our route. So I will make one route here only. For some projects in the course, I have made multiple routes also, like one home route and one predict. In this case, we will make one home route only. Okay, just give it route, and let's home route is this only. Okay, and our methods, okay, methods will be both get as well as post, like this. Okay, and after that I will create one function. You can just name it anything. I'm naming it index. Okay, first of all, let's initialize a variable prediction. It is none. By default it is none, right? If we get a request, if request dot, I think we have not imported uh, request, right? Okay, so in the from flask import flask render template, we have to import request also. Okay, now it will work. Just go. If request dot uh, method equal to post, it means someone is calling a post method on us. So what you will do basically, let's make it inside try except block so that we can handle exception also. I will write input data, input data will be float. We will convert it into float. Request dot form particular feature. Okay, now what is this feature? You might get confused. Okay, but I will tell you in a bit, don't worry. For feature in features. Okay, so basically what we'll be doing, we don't have that much time that we will create a HTML page again and again. Okay, okay, it means I'm creating a form. I have to create one label for operation mode, temperature Celsius, vibration hertz. So it will consume too much time. So I will be making instantly. I will tell you the way how to make them instantly. If you have too much methods, how to make them instantly, how to make a HTML page instantly, basically. So basically what we are doing, we are collecting all the feature input that from that form, whatever user have input, and our input is stored in this input data. Okay, our input is stored in this input data. Now we have to reshape it. Okay, we have to reshape our data because it is in 1D format, right? So I will write input array. Okay, input array, and it will be np dot array input data. We will convert this input data. Okay, currently it is in a list format. Okay, input data is in list format. We will convert it into array because machine learning only understands array. And we will reshape it also. Reshape uh, sorry, 1 comma minus 1, so that we can get the desired result. Now you have reshaped it. Now you have to perform scaling. So I will write scaled array equal to your scalar dot transform, scalar dot transform on input array. Okay, because whatever user have done, it is normal data. It is not scaled, but your model was trained on a scaled data. Okay, so make sure you have to use the same scalar that was used in the model training to scale your data. Okay, so that's why we have saved our scalar during data processing. Now we are using that same scalar to scale our new data. Okay, that user have input. Okay, done. Now we have to do prediction. So I will just write prediction pred equal to uh, model.predict on this scaled array. Okay, and I will get the 0th index. Okay, then I will get the prediction equal to labels dot get, because it will give me 0 1 2, but I want to get it in high, low and medium, like this. Okay, I think I have, okay, label dot get, and I will write pred. Okay, so it will give me whatever label. Suppose if the pred is 0, it will give labels dot pred. So 0 is defined by high, so it will show me in the prediction variable, it will be stored high. Okay, suppose in the pred we got 2, so in the prediction it will store medium. Okay, like this. And we have to pass one more thing here. Suppose if we are not getting anything, suppose if pred is 5, but we don't have anything in labels 5. Okay, but we will not get, don't worry, but we have to wow, but we have to show something, right? So I will show here unknown. Okay, like this, so that we can identify our errors, right? So okay, so you are getting prediction. Now let's do the exception. Except exception as e, I will write prediction. Instead of prediction, I will show my error. Okay, in the same where my prediction is getting shown, I will show my error if if we are getting any error. Okay, so I will just show f error. Okay, I will just show that error. Okay, now I have to return the template. Okay, I have to return the template. So I will write return render template, like this, and I will write I will call my index.html that we will create now, index.html. Okay, I will pass my prediction equal to prediction uh, to my HTML. Okay, and I will also pass my features equal to features to my HTML app. Why we are passing this features, I will tell you in a bit. Okay, after that we will run our app. So for running, I will write if name equal to main. Okay, if someone run this file, I will run it app.run. Okay, I will write let's set the debug mode equal to true, and let's set the host equal to 0.0.0.0, because later you will be uploading it in your VM instances and all, deploying it on the VM instance. That's why you need a perfect host so that it can accept any IP addresses, and your port will be by default 5000. Okay, then so your application.py is done. Okay, let me give you a summary. These are some basic imports. Initialized your Flask app, defined your model path and scalar path and loaded them. All the input features, all the labels, output labels, your app.route for doing the prediction. Okay, now all things will get clear as soon as we make our index.html. So in the templates tab, sorry, templates directory, create one file index.html, like this. Okay, now here comes the main part. Okay, we have sent something, we have sent features and we have sent prediction. It means we are sending these two things from application.py to index.html. Okay, and you can receive them using Jinja2 templates. You can't connect directly Python and index.html files. Okay, so you need a bridge, and Jinja2 template, basically Jinja2 is a lightweight framework that connects your Python with your HTML files. Okay, now basically first of all you have to create some basic code, that is your doc type HTML, then your HTML tag where your language will be English, like this. Okay, now we will go inside your head tag. Inside head tag, it will be your meta character set, and your meta character set will be UTF-8 encoding, like this. Okay, then your meta name, let's name it view port Okay, then it will be our content will be width equal to device width, like this. And let's make a comma, initial scale equal to 1.0, like this. Let's end this, and after that let's give a title to our web page. Let's name it, and let's give the title name smart manufacturing machines efficiency prediction, like this. Okay, so this will be a website title. Okay, then I will create some styling also later. Okay, so I will write here uh, let's create styling later, right? Let's create styling later. Let's create an external styling. Okay, let's keep it for now for this only. Okay, your head tab is done. Now let's create our body tag. Okay, in the body tag, first of all, let me give one heading, and I will give the same heading as my title, smart manufacturing efficiency prediction. Let me copy this, paste this here. Done. Now I will create one form. Create one form. Method will be post. Okay. Let me close this form. Okay. Go inside this. Now, our application.py is sending all the features. Now I don't want to create features one by one. For first of all for operation, then for what are the features names? I forgot. Okay, temperature, vibration, power consumption. It will take too much time. So I will create them in an instant. How? Using Jinja to template. I will write curly bracket percentage for feature in features. Okay. So what is it is doing? We are sending this features variable, and features variable have what? Our features. Features variable have this. So we are iterating over each variable. Okay, we are iterating over each column. Okay, we are iterating over each for feature in features. Okay, once you have done this, I will create label for each of them while iteration. So I will write label for let's give it like this, label for equal to, and I will write, give the name as this, just write double curly brackets and give the name feature. Okay, and just give it like this, and here also just double curly brackets and pass feature, like this. Okay, wherever you want to name the column, just name feature. Okay, and same way you will be doing with the input type also. Input type equal to, let's take it text. Okay, because we are later converting them into float. You can see, although we are taking them in text, but here we are converting them into float, so there is no issue. Okay, and then name should be your same, so I will write same feature. Okay, name should match the above, right? So I will write here feature, and let's give it require. Okay, required. Okay, so it should be required. Let's give a br so that we can get a break. We will get separate lines basically. Okay, now we have to end this, for loop. So for writing, you will write just a curly bracket again percentage sign and for, like this. You have used this multiple times now. Okay, so I think you understand now Ginger template, how to use them. Okay, so with this you are iterating over each feature, and you are making label for each of them. Okay, so instead of making separately for each of them, I have created in one instant. Okay, but if you want to make a more detailed input boxes for users, then it will not work. You have to create them separately only. Okay, but since this is an easy project and our main focus is on something else, that is our VM instance GitOps, so we can just make haste here, but don't make haste there. Okay, now let's create one button. Okay, let's create one button for prediction button, and let's give its type. Its type will be submit. Okay, now let's give the button name. Let's give it predict, like this. Okay, done. So this was your form is now made. Now you are getting two things from application.py. I already told you. You are getting features which we have already dealt with. Now we are getting prediction also. Okay, so we have to show the prediction also on the same web page. So for that, I will write again that Jinja 2 template, another Jinja 2. If prediction, okay, if my application.py is sending some prediction, okay, then what it will do, let's create a h2 tag. Okay, let's create a h2 tag and let's show our prediction here. Let's show our prediction here between two curly brackets, prediction. Make sure this name matches with your application.py name, prediction, and it should also be prediction, right? And now we have opened this if prediction, so we have to end this also. So I will just write percentage and if percentage, like this. Okay, so you have created your HTML page also, simple. Okay, now we have to do the styling. Okay, so what I will do basically, I am going to link my, I will just write link relative, okay, style sheet. Okay, and I will write just href, and I will pass the path here. My path will be static style dot css. Okay, like this. Save it. In the static, search for your static here. I will create one file, style dot css. Make sure the name are same. Okay, now I will just copy my index.html code. Okay, and just go to my chat GPT and paste this and ask my chat GPT, please generate a beautiful and interactive CSS for the above HTML code, like this. Okay, I have made some spelling mistakes, but please ignore them. Okay, so it is giving me smart and MFG style. I don't know what is this MFG style, but let's hope it is good. Okay, okay, so it is giving me a very big CSS. So let me copy this, and first of all let's run with this only, then we will check. Okay, so let me open my terminal. I will just write python application dot py, press enter. Okay, so my application is running. Let's check. So it is like this. Okay, now let's look at the makeover. In the style.css, let me paste that code. Okay, whatever the code is there, let me refresh. Okay, still not that good. Okay, uh, I'm not impressed. Let's ask it to make it good, make it more good. If you want to make changes in HTML, make them. I am giving the permission to it to make the changes in HTML also, because CSS generally works better if you have div classes. Okay, but you can see our HTML files doesn't have any div classes there. Okay, there is no divs. Okay, that's why CSS is not able to do that much. Okay, so it is saying it has enhanced it, but I'm not getting what it has enhanced. Let's check. It is only changing the color. Okay, now you can do your prediction. You can just do a 3-4 more iterations on the chat GPT and you will get a more good layout. You can just make the layout in form of horizontal, not vertically, horizontal. Okay, let's ask the chat GPT. Uh, make the form in horizontal layout and good layout. I don't know how to do prompts. I don't know what it is doing. I think it's a O1 model, right? That's why it's checking its own code again and again. Let's check how it will work. Who knows? Okay, it has destroyed. Let's use the previous one only. Chat GPT, you are great. Now operation mode, let's keep it 0 since it was an encoding. Temperature, let's 25. Vibration, let's give it 25. Power consumption, let's give it 100. We have to just check whether it is predicting or not. Network latency, let's keep it 12. Packet loss, 21%. Quality control, 10%. Production unit, 450. Okay. Predictive maintenance score, let's keep it 20. Error rate, 11. Year, 2024. Month, let's keep it 5. 5. And day, let's keep it 5 only. Hour, let's keep it 0. Let's do the prediction. Okay, so it is predicting low. Okay, that's good. It means our model is predicting and it is working fine. It means we can deploy this model. Okay, it is working fine. So that was it for your user app building stage. From the next video onwards, you will be making your, first of all, you will be doing your data versioning and code versioning using GitHub only, because we are making a GitOps project, right? So GitHub will be the truth source, and we will also be making Dockerfile, manifesting files. Okay, you will see in the next video, and from the next video, your main part will start. Okay, so be prepared, be patient, and good luck. So let's move to our next video. So hello everyone. In this video, what you will be doing, basically from this video, your main CI/CD part is going to happen. Your main GitOps, okay? Because previously you have done is almost similar, okay? Almost similar to your previous projects only. So that was not a big issue, okay? You have done just your Jupyter notebook testing, data processing, model training, and you have built your user app. Now, in the root directory only, you will create your Docker file first. So I will create one file and I will name it Docker file. And make sure in the VS extensions, you go here and just search for Docker. Okay. And make sure you install this Docker extension. Okay. After that, your Docker file will be same as your previous projects. So I'm writing here. Let me write the code first, then I will explain. From Python. Okay. It should be capital. From Python 3.9 base image, your work directory will be app. You will be copying all the contents from your local directory to your this container app directory. Okay, then you will run pip install -no -catch -dir -e full stop. Okay, then you will be exposing the port 5000. Okay, then you will list your environment variable flask app equal to application.py. Okay, then you will run using your command here python and application dot py. Okay, although I have already explained this file many times previously also. So first, with the first line, what you are doing, you are using the Python 3.9 base image. You can also use slim image if you want. Okay, but I will be using the base 3.9 image. With 3.9 means Python 3.9 version will be installed in that image. Okay, then I'm creating a work directory inside my Docker container that will be app. Okay, now I'm copying all the contents. Copy dot means all the contents. So I'm copying all the contents from here to my app directory. Okay, now this, what this no cache directory is doing, it is removing all my previous cache memory. Okay, and after that it will run pip install -e full stop, so that my all the dependencies, all the packages will get installed. Now one more thing, here it is expose 5000. What it is doing, let me open my application.py. Make sure your application.py app.run is like this. Okay, app.run host should be equal to 0.0.0 and port 5000. Flask runs on 5000 by default. Okay, and debug, it's optional. You can either set it to true or false, whatever you want. Okay, so make sure these two are there in your app.run, and whatever port you are giving here, make sure you give the same port here also in the expose. Okay, then you will be defining your environment variable. And now how you run your Python application? You run using Python application.py, right? So same here, cmd Python application.py, just like you run on your local PC, same you will run inside your Docker container also. Okay, simple enough. Okay, so with this you have done your Dockerfile creation. Now you will be creating your Kubernetes deployment. Okay, and I said it will be a bit different. So what you will be doing, you will be creating one folder and you will be creating a Kubernetes manifests files. So I will give the folder name manifests. Okay, manifests. Now inside this manifest, you will create two files. Okay, you will create one deployment file, you will create one service file. Generally, in the previous project, we just create one file and we integrate both our deployment and service in that file only. But here we will be creating separately. Okay, and then you will be creating deploy deployment dot yaml. Okay, now inside the manifest only, you will create one service. Okay, service dot yaml. Okay, first of all, let's write the code for deployment.yaml. Let me cancel this service. Okay, so what you can do, basically you can copy your code from the previous projects only. So let me open my previous projects. Okay, let me open the GitHub. Hmm, let me open repositories and let's go with the MLOps project 8 only. That was our previous project. Here we have our Kubernetes deployment.yaml. Basically, this Kubernetes deployment.yaml is divided into two parts. You can see one part here, one part here. The above part is the deployment.yaml. The below part is the service.yaml. You can also integrate them into one, but since you are doing a GitOps project, I will recommend you to do separately. Okay, so let me copy this much and paste it in the deployment. Okay, now first of all, whatever version you want to give, basically you will give apps version 1 only. Kind is deployment. Okay, you have basically two kinds, whether it is deployment, whether it is service. So this is our deployment.yaml, so it will be a deployment file. Then you can name it any name. Okay, you can give it any name, but make sure the name you are giving here, that should be here also and here also and here also. Okay, and how many replicas do you want? So we will go with two. Okay, since this is a testing project, you can make 5, 10 according to your needs. Okay, now the main part is image. Okay, so I will be removing this much. Okay, I will be removing this much, and we will fill that image section later. Okay, we will fill this image section later. So basically we will be pushing our image to a Docker Hub repository. Okay, so when we get that URL, we will paste that image URL here in the image section. Okay, but for now you will keep it empty. Okay, and in the container port you will list your port where your Flask app will be running. It is running on 5000 port, right? So we are listing 5000. Okay, simple enough. Now let's open the service.yaml. Let's open service.yaml. Let me copy this and paste it here. Okay, so API version 1, kind will be service this time. Metadata, you can name it anything. So let's name it my service. Okay, let's name it my service, and on which this service will be applied on our MLOps app. Okay, but let's change a bit here. No, I think it's fine. Okay, I think yeah, it's MLOps app only, right? So whatever the name you have given here in there, sorry for my bad English, whatever name you have given in the deployment.yaml, make sure you give the same name here also in the selector. Okay, your deployment name should be here, so that now service knows on which deployment we have to apply this service. Okay, then in the ports, uh, you will be giving port equal to 80, target port equal to 5000. Target port will be the port of your where your Flask app is running. Basically, your Flask apps run on 5000 port. You have already listed. Okay, then you have to change the type. You will be giving the type node port. Okay, you will be giving the type node port. Okay, so only this much was needed. Okay, you can also remove this protocol also. Okay, you can just remove this protocol. You don't need this basically. Okay, just remove this ports, port equal to 80 and target port equal to 5000. Okay, this 80 is the port where your service is exposed. This 5000 is the port where your application is listening. Okay, so don't get confused. So okay, so you have created even your deployment.yaml. Okay, I'm not saying you make this your own. You can just copy from the resource section where I have given the code. Okay, you can just copy paste and change the some syntax according to your need, right? Basically only one thing you have to change, that is your image. Okay, only one thing, and the replicas according to you, because image will be different for different user, because your Docker Hub username will be different, your Docker Hub image name will be different and all. Okay, so with this you have created your Kubernetes deployment files also. Now what you will be doing, you will be pushing your code to your GitHub repo. Okay, so first of all I will create one .gitignore file, git ignore. Okay, here I will list all the files that I don't want to push. First of all, I don't want to push my venv. Okay, and then I don't want to push this project management file also. So let's copy this relative path and here. Then I also don't want to push logs. Okay, and one more thing, you can create your training pipeline also. Okay, I have created many time previously also, so you can just create it like this. It's very simple. So I have not covered this training pipeline in this project, and it's not necessary also that much. You can just create it according to yourself, right? And what more files I want to ignore? I don't think there are much files, so only these three files I want to ignore. So now we have made our .git ignore. Now let's create our repo. So I will go in my GitHub, just go and sign in, login up, whatever you want to do. Just create new repository and let's name it our GitOps project. Okay, let's name it GitOps project because it is a bit different, and I have already explained how it is different in the introduction video. Okay, so I will name it GitOps project, and since this is our project number 9, okay, so I have named it project number 9 and just create it. Okay, now just copy some commands. First of all, let's do git init. Open your terminal, make sure you activate your environment. Let's paste git init. It has initialized an empty repository. Then git branch. Let's copy this, paste it here. Then git remote add origin. Let's copy this. It will connect our GitHub repo with our local directory. Okay, now let's push our code. So for this, first of all, add all the contents. So I will write git add full stop. Full stop means all the contents. Then I will write git commit -m and write any message. So I will write commit message and it will commit all the things. Now you will write git push origin to main. So it will push all your codes from your here to your GitHub repo. Okay, so it has done. Now let's refresh. Okay, now you have got all your code and it is your main branch and everything is there. Okay, so with this video is complete, and I am telling you from here on your CI/CD deployment has started. Okay, so I will be breaking all the things into step by step so that you don't get confused in each video. Okay, so I will be making each step in a different video. Okay, so that it will be easy for you to understand and all, right? So in this video, what you have done, you have created your Dockerfile, your Kubernetes manifests files, your deployment and service YAML basically. Then you have done your data and code versioning using GitHub. Okay, so now let's move to a next video. Hello everyone. So in the previous video, you have done till your data and code versioning using GitHub. Okay, so in this video, you will be configuring your VM instance. You will be downloading and installing all the things that you need in your future deployment process. Okay, so first of all, let me open my browser and let's search for GCP. Okay, let me open the GCP. Make sure you have made account here and open and sign in into that account. And you are here on your Google Cloud. Okay, now you will search for VM instances. Okay, you have got the VM instances option. Just open it and you will get an option to create an instance. So basically, what is VM instance? I have already explained in the introduction video. I will give a summary here. Basically, it is just like renting a PC online. Okay, so we are renting a PC online. Okay, so let's create one instance. Now you can give it any name, whatever name you want to give. So let's give it GitOps machine. Okay, basically we are doing GitOps here, right? And you can select any region according to your, and I am selecting US Central one. That's my personal favorite. Okay, now so for here we have to select. See, we will be installing Minikube as I've already told in the introduction video. So Minikube requires a good amount of RAM and all. So we will be selecting a pretty much good sized RAM PC from here. Okay, so what you will be selecting here, you will select E2 only. Okay, that is given by default generally. So you will be selecting E2, right? Now go below and here where you are saying E2 medium, it is having, you can see 2 CPU, 1 core, 4 GB memory. But this much is consumed by Minikube only. Okay, Minikube minimum requirements are 2 CPU and 4 GB memory. So how you will do additional task there, right? So just open this, go in the standard and either select with 16 GB RAM or 8 GB RAM. It is E2 standard 2 either or E2 standard 4. Okay, this much are enough. So I will be going with E2 standard 4.
And don't worry, you have your free credits. Okay. And since we are doing for this for production sorry, testing only, we are not going for production. So for testing purpose, we will go with E2 standard 4. That is our 16 GB memory and 4 CPUs with 2 cores. Okay. Done. So it is monthly estimate around $100. Okay. So I think that fine. Then go on the OS storage on the left pane, OS and storage. Now, which OS do you want? Okay, by default there is Linux 12, but we will not be going with the Linux 12. Just go on the change. Okay, here in the operating system, we will be downloading a Ubuntu system. So search for Ubuntu. So you got here Ubuntu, just select it and it will automatically select this Ubuntu 20.40 LTS. LTS generally mean long time support image. Okay, so make sure you go with this version only or whatever by default it is recommending you, right? Now it is only giving us 10 GB of hard disk space. Okay, this space is your hard disk space. The previous one was your RAM. Okay, so 10 GB is not enough for us. So I will go with 256. You can go with 128 also. So I will go with 256. Let's select this. Okay. Okay. It is showing you might not have enough quota for this. Okay. Let's change then because since we are using free version, right? So let's go with 128 then. Okay. Now it is not showing any error. Okay. If it is showing you error here, since you are using the free version, so there are restriction on free version, right? Now it is not showing that you will exceed your quota limit. So I will recommend you to go with 128 GB. It is fine because 20 GB is required by I think Minikube only. So rest will be with you only. Okay. So our monthly estimate has now crossed $110. That's fine. Now in the networking, in the left pane, go with networking and allow all these things. Allow HTTP, allow HTTPS, allow load balancer, right? And IP forwarding, enable it, right? Because we will be forwarding IP during our VM instance making. Okay, you will see in the next videos. So now go with observability, nothing to do here. Security, nothing to do here. Advanced, nothing to do here. So let's create. Okay, so it is creating our VM instance. So it may take around some minutes. So you can wait till then. Okay, so let's wait. Okay, we will come back after this has been made successfully. Okay, so now you have got your VM machine ready. So you can see the status is green ticked. It means your instance is running. You have got your internal IP, you have got your external IP and everything. Okay, now you have to connect to this instance. So you will connect it using here. So you can see there is an option connect. Just go in the drop down and open in browser window. So it will open another browser window like this. You can see here, this is our browser window. So it is transferring some login keys to our virtual machine so that we can access. Okay. So you have to authorize it. Okay. It will automatically authorize your and it will connect to your SSH server. Okay. You will be inside your machine now. Okay. Now you are inside your machine. You can see here it is your machine. Now, first of all, what you will be doing, you will be cloning your all the GitHub content from there to your machine. Okay. So go here in your GitHub directory, that is your GitHub's project 9, your GitHub repo. Go in the code, make sure you are in the HTTPS, just copy this link and let me open the VM instance terminal here. Okay, and I will write here, you can see here, git clone. And since you can't directly paste using Control V, what you will be doing, you will be right clicking and paste. Okay, and press enter. So it will clone all your contents. Okay, let me clear the screen. For clearing, you will write CLEAR. Okay, done. Should we maximize this? Okay, let's maximize this. This. Okay, now I will write ls, so it will show me all the content. Okay, now you can see you have your GitOps project 9 also here. Okay, so I will be going inside this GitOps project 9. So you will write cd GitOps project 9. Okay, press enter. Now you are inside your GitOps project 9. You can see now there is it is in the blue color. Okay, now you can go with again ls, and you will see all the contents inside your GitOps project 9. You can see you have your Dockerfile, application.py, artifact, manifest, notebook, pipeline, requirement, setup, src, static, template. It means all the things are perfectly cloned, right? uh, so it means this much is successful. Now you have to install your Docker inside your this VM instance. You have to install Docker. So for installing Docker, what you will do, just open your browser, and in the browser search install Docker on Ubuntu, since it is a Ubuntu machine. Okay, search here, and you will get the first link only, install Docker engine on Ubuntu. Okay, make sure you watch the introduction video, then you will get a clear image why we are installing all these Docker and all, right? Now, and we have to go little down, down. Okay, and you will get install using apt repository. Okay, just copy this first command whole. Okay, this whatever this whole command you have got, copy it using this button. You will get a button here for copying. Just copy this, open your VM machine. Okay, right click, paste here. Okay, so it will automatically install. Sorry. So it is doing. Press enter again. Okay, so it has done. Okay, you can see it has or done all the first process, right? Now you have to go again to that website and copy the second command. You can see install the Docker packages. So just copy this command and paste it in the virtual machine and press enter again. It is asking for your permission, why, whether to continue or not. So I will give why. I know it's a bit, so let me minimize it so that I can show you like this. I'm not able to maximize, I don't know why. Okay, so you can see it correctly now. Otherwise it was going too down. Okay. Sorry, I have got a bit cold. Okay, so it has completed now. Now what you will be doing next, basically you will go again to your this browser only, and it is for verifying whether you have successfully installed or not. So just copy this, and it is just for validation purpose. Let me clear the terminal screen and let's paste it here now. Okay, and you can see it is printing the message hello from Docker here. Okay, it is printing hello from Docker. It means it is working fine. If there is a message here hello from Docker, it is fine. Let me clear the screen again. Okay, so with this you have installed your Docker on your virtual machine perfectly. Okay, but there is one problem. Each time you have to run Docker, you have to write sudo in the front. Okay, you can see here, you have to write like this: sudo docker run hello world. Suppose if you want to build your image, you have to write sudo docker build. Suppose you have to push your image, sudo docker push. So it's a bit, we can say, not good, right? We just want to write docker build, docker push. We don't want to add sudo each time.
So for this, what you will be doing in the same website only, go at the end, below, at the end. You can see here, continue to post installation steps on Linux. Open this website. Okay. And here you have got the commands. So you will create one Docker group. So just copy this. Okay. And open your VM instance, paste here. Okay. It will see, you will get a message, already exists. Docker already exists. Okay. Now open the second command, copy it, paste it here, press enter. Okay, it got executed. Now open the third command, copy it and paste it in the VM instance. Done. Now if you will run the same thing, now you are not adding any docker, sudo. You are just running docker run hello world. You are not writing any sudo at the front. Okay. Now let's check whether it is working. Paste. And you can see you have got the message hello from Docker still. So we have fixed that problem of sudo now. Okay, so that's good. Let me clear the screen. Okay, so this much is good. Now you have installed your Docker. Okay, now you have to go on the same page below. Okay, you have still not configured it. You have installed the Docker, but you have not configured it, right? So go on the below only, in this page only, where you just did your all the things, the Docker group. Just go below. Here you have the option to configure. Okay, just copy these two commands. That is your enable Docker service, enable container service. So just copy it and paste it in your VM instance. Okay, so it will start executing. So you can see it has enabled your Docker services. Okay, you have to press enter. Okay, so it have enabled your container services as well as your Docker services. So now you can access your Docker easily. Okay, now Docker is all set up now. You have installed it, you have configured it, all things done. Okay, you can also check also. How you can check? Let me clear the screen so that you get a better view. What you will write? You will write systemctl, systemctl. Okay, status Docker. You will get the status of your Docker. Just run it and you will see it is active running. So if you are seeing this active running, it means your Docker is perfectly running. You can just press Ctrl C and you will get out of this. Let me clear the screen again. Done. So you have got your Docker running. You can check one more thing. You can check Docker PS and you can see there is no container running. Okay, you can see there is no container running currently. It is empty. So, but soon the containers will be running. Okay, how? Because we will be installing. You can also check one more thing. You can check Docker PS -a and you will see your hello worlds, because you have run your hello worlds program 2 times. So it is showing it is run here also 2 minutes ago, 4 minutes ago, but they have now exited because it is just a testing program. So it automatically exits. Okay, it does not run for infinite time. Okay, it runs and it get exited. Okay, so we have run 2 times, so that's why it is showing us the history. Okay, so with this your Docker is all installed and configured. Our next part is to install and configure our Minikube. So let's go with it. First of all, go in the browser only, uh, just search for install Minikube. Okay, and you will get the first site, this Minikube start. Just open it. Let me close up the other tabs. Okay, so Minikube requires 2 CPUs, 2 GB of RAM, 20 GB of hard disk. So you should have these. Okay, our operating system is Linux. Okay, architecture is this only, stable and binary download. Make sure you select these. and you will get these two commands. Okay, so just copy them from here. There is a button for copying, you can see on the right. Okay, there is a button to copy it. Just go on the VM instance and paste these. Okay, my connection failed. I think maybe due to internet connection. Let me again connect to my internet. I don't know why it's automatically got failed. Let me authorize it. So you can face this problem, but there's no thing to worry. You just have to go inside your GitOps project 9. Only this thing you have to done. So I will just go ls, and you will go inside your cd GitOps and project and 9. Okay. Okay, once you are inside your GitHub project 9, you can just continue from there. So I've copied the command. Okay, this minikube commands. Just go here and paste it in the terminal. So okay, it is installing your minikube now. It has installed because we have taken 16 GB of memory, and that's why it is installing fast. Okay, and it will give you. Now you have to start your minikube. Now you have already learned in the project, I think 4 or 5, how to start a minikube. You just write minikube start. Okay, so if you are not seeing the command, it is minikube start. Okay, just press enter. So it will download Kubernetes, and it will start installing your minikube. Okay, so it is installing. Let's wait. Now till your this minikube is installing, you need one more thing. You need kubectl. Okay, so I will write in the browser, go to the browser and write kubectl. Okay, and you will get the first command only, install and set up kubectl on Linux. Okay, just open this website. Okay, make sure you are on the Linux page. Okay, because our machine is of Linux. So you will get the first command here, download the latest version with this command. So you will copy this, Control C, open your VM instance. Okay, so it has installed your minikube now. So after the minikube is installed, paste your this command that you just copied, press enter. Okay, now what you will do next is second command. Okay, second command is optional. It is just for validation purpose, whether it is perfectly installed or not. So just copy this and paste it on the terminal. It's optional. Okay, okay, so it is showing us this. So it means our kubectl was installed. Okay, its binary file was installed. Let me clear the screen. But now you have to install the final kubectl. For this, you can either go with these commands. These are your commands. Okay, but we will be going with a different approach. Okay, what you will do, just go below, and we will be using snap module. You can see if you are a Ubuntu or another Linux distribution that supports snap. In Ubuntu, snap is by default. Okay, snap is by default there. So you can just install kubectl using snap in a instantly. Okay, so just copy this snap install kubectl classic, open your VM instance, paste the command here and press enter. Now it will not install. Okay, it is showing us access denied. You can see access denied. So what you will write, it is showing us try with sudo. So you will write sudo, then you will write your command, that is your snap install kubectl classic. Then you will press enter, and now it will install. Okay, so you have to write sudo in front, right? Now you can see kubectl from Canonical installed. Now to check whether it is installed or not, just copy this command kubectl version client and paste it on the VM instance. Press enter, and you will see you will get a client version and customized version. If you are seeing this, it means your kubectl is perfectly installed.
Okay, if you are not getting anything, it is showing kubectl not installed or kubectl command not found. It means you have done some mistake and all. Okay. Okay, now what you will do, you have to just run one command, that is minikube status. Okay, spelling is wrong, status. Okay, just press enter. So it is showing us. Okay, I refreshed it. Ah, yeah, what I am doing. I, I just pressed the backward key. Okay, let's again connect what we can do now. So basically with minikube status, you can check whether it is working fine or not. So I will go with ls. Let's, you can see also here now the snap module is installed, but you will not go inside snap module. You will go inside your GitOps project and 9. Okay, make sure you are doing everything inside this GitOps project 9. Okay, now your minikube is installed. You don't have to perform all the steps again. You will just write minikube status. Okay, now you can see host running, kubelet running, API service running, kube config configured. If you are getting these, it means till now you have done everything fine. Okay, then what you will be doing, let's check kube ctl get nodes. Press enter. You will see your minikube here. You can see your minikube is here. It means your minikube is perfectly running. It is ready. It is in a ready state. Okay, so perfectly fine. Okay, then you will write kubectl cluster info. Basically cluster hyphen info is there, cluster info. Okay, so you will see the DNS on which your Kubernetes is running. Sorry, IP address where your Kubernetes is running. So your Kubernetes is running at whatever this IP is there, 192.68 and everything. Okay, so it will be of use later, but for now you have to check whether it is showing some IP or not. Then you will write your docker ps. Okay, now as soon as you write this docker ps, you will get one. Previously you were not getting anything inside docker ps, but now you are getting this gcr minikube. Okay, you are getting the name minikube. So it means your minikube container is running inside your virtual machine now. Okay, so that's good news. Okay, so that was in this video. We have done our all the VM instance setup. We have installed Docker in our VM instance. We have installed minikube in our VM instance. We have installed kubectl in our VM instance. And why we are doing this, please see the introduction video. Only then you will get to know why we are doing all these processes. Okay, introduction video is most important for this project, right? So all the configuration for our VM instance is done. Now our VM instance is ready to go. Okay, let's move to our next video. Hello everyone. So in the previous video, you have configured your VM instance. Now you will be configuring your Jenkins container, because we require Jenkins for our CI purpose, that is continuous integration. For CD purpose, we will be using ArgoCD. So firstly, we will be configuring our Jenkins in this video. Okay. So if you have done my project 1 and project 2, okay, so this will be a piece of cake for you. Okay, because what you will be doing, you will be following the same steps that were from your project 1 and project 2, but the only difference is that in project 1 and 2 it was in the local machine, now it is in a virtual machine. Okay, the only difference is that. Okay, now let's start with the video. Okay, so since you will be running Jenkins in form of a container, okay, you will be running Jenkins in form of a container, just like your minikube is running, you will be running your Jenkins also. Okay, you have already done this in project 1 and 2. Okay, so what we call this process, we call this DIND. It means Docker in Docker. Okay, So we will be running, we have minikube inside a Docker, then Jenkins inside a Docker, and Jenkins will be inside that minikube. So Docker in Docker. Okay. So first of all, you will write Docker network and write ls. Okay. So it will show you all the networks. First one is bridge, host. You have got your minikube here. Okay. So you have to make sure that minikube and Jenkins run on the same server. Okay. They use the same network. Okay. So what you will be doing, I have given one notepad file in the resource section. Just go there and open it and copy this command whole. Okay. I will be explaining this command. First of all, whatever you want to name your container, Jenkins container, you can give it. Okay. I am naming it Jenkins only. Okay. You can give it according to yourself. Okay. And then it will be your port where your Jenkins will be running. Okay. Then Jenkins have agents, and agents will be running on this 50,000 port. Okay. Then there is your Docker socket mounting. Okay. You can just copy and paste. If you want to understand this in depth, just go with the project 1 and project 2. Okay. And then this is also, now we will be using the user root. Okay. Our user will be root. Now we'll be accessing our Docker group using our Docker group ID. This Docker GID means Docker group ID. Okay. And this is the main thing. Okay. Our network will be minikube. So our network will be same as our minikube. And you can see here, whatever you name have, whatever the name you have here, in my case it is minikube. Okay. So you will give the same name. Okay. And after that you will be writing Jenkins LTS. It means we will be using Jenkins long type support image. So just copy this whole. Okay. Go in your VM instance and paste it. Press enter. So it is pulling your Jenkins image locally and it is installing that image. Okay. So wait for it to get completed. Okay. Now you will write Docker PS. And now you will see, let me maximize it. You will see you have got one Jenkins image also. Previously you have only minikube image, but now you have your Jenkins image also running. It means your Jenkins container is also running now. Okay. And you can see that this is 7 seconds ago. Okay. Got it. Let me clear the screen. Clear. Okay. Now what you will do, you will write Docker logs and whatever your container name is. In my case, it is Jenkins. Okay. So you can write Docker logs Jenkins, press enter, and it will give you a password. You can see it is giving us password. Please use the following password to proceed to installation. So this is your password. Okay. So just copy this password. Now, how you will run this password? Basically, the problem is just go to your GCP. Okay. Go in the VM instance. Just copy this external ID. Okay. You will paste it here in the browser. Okay. And you have given the port 8080. You have given the port 8080 for Jenkins, right? So you will write colon 8080, press enter, and it will open your Jenkins. Okay. And you have to give the password here. But in your case, it will not open. Why mine is opening and your will not open? There is a reason. Because I have given the firewall settings previous for my previous projects also. That's why it is running. But if you are doing it for the first time, you have not given any firewall permissions. Firewall permissions are just like if you have used AWS, these are just like your inbound rules. Okay. So how you will get access? Just go on the GCP cloud and here search for firewall. Okay. So you will get option firewall. Open the new tab. So it is opening a new tab. So okay, so I was making previous projects also. That's why I have here this allow Jenkins, right? That's why my file is opening. Okay. Suppose if I delete these two,
Okay, suppose I have, if I delete these two, okay, let me delete these two, then you will see this Jenkins will not open. Okay, uh, let me delete these. Okay, firewalls rules deleted. Now these are your default rules only. You can see these are your default rules that are by default provided by GCP. Now if I refresh it here, you can see it is not showing us anything. Okay, can't reach this page. Previously it was reaching, but now it is not reaching. So how we will create your firewall policy? Just create on this create firewall rule. Just open this and just name it anything. Okay, you can name it anything. I am creating it allow. Just give it allow Jenkins or anything. Allow Jenkins. Just give it allow MLOps. Okay, just give it any description if you want. Logs will be off. Network will be default. Okay, by default network will be default. Priority, let's set it to 1000 only. And direction will be ingress. Ingress means inbound rules. Okay, if you want to access something from inside a VM instance, and our Jenkins is running inside a VM instance, right? That's why we will go with ingress. It means inside. Okay, then action on match, it will allow. Okay, now specify target tags. Here you will write all instances in the network. Okay, all instances in the network. And source filter IP4 ranges, that is by default given. Okay, now in the source you will write 0.0.0.0. Okay, 40 will be there, and then slash and 0. Okay, like this. So it will be like this, 0.0.0.0 slash 0. Okay, then protocol and ports, I will say allow all. Why? Because in the next videos you will be configuring your ArgoCD and all. So why to give the ports again and again? Why to create different firewall rules? So I will give this firewall rule all the permission. Like it will give access to all the ports. We don't have to make another firewall rule for ArgoCD and other things. Okay, one firewall rule is enough for all. Okay, so just create it. Okay, so it is creating allow MLOps and it has created. Now you will refresh your this same. Now you are getting the access, right? So now just paste the password that you copied. Okay, whatever the password you just copied, just copy this and go in the Jenkins, paste here and continue. Don't save this. Then go with install suggested plugins. Okay, so it will install your Jenkins plugins. You have to wait for some time. Let's wait. After that you will be creating one user also. So wait, it will depend on your internet connection basically. Let me drink the water. Hmm. So it is done. Now it is asking for creating the admin user. So let's create. Okay, let's give it sid 9760. Password I will give it's secret. Okay, you can give it any password according to yourself. Now let's confirm our password. Then give your any name and email address, but make sure you remember your username and password. Okay, just don't give it anything. Then save and continue. Okay, I will save it and then save and finish. Then start using Jenkins. Okay, now in the you have inside the Jenkins dashboard. Now you will be getting one error here, so don't panic. It will be this building on built-in mode can be a security issue. It should be distributed. Basically, it is telling you to build agents instead of directly using Jenkins. But we don't want to build any agents, right? Basically, during the making of my this Jenkins container, I defined two ports, one 8080 for Jenkins, 150,000 for agents, right? So it is telling me to set up agents, but I don't want. So just dismiss this warning. Okay. So just dismiss this. Okay. We don't want any agents. This is a MLOps project, and since we are not making it in production, okay, so we don't need agents, right? Okay. Now just go on the Jenkins dashboard. Here, go on the manage plugins and go in the plugin sections. You want some plugins. Just go on the available plugins. Just search for plugins. Just write Docker. Okay. Just select your Docker plugin. Okay. Then select your Docker pipeline plugin. These two plugins. Then select your Kubernetes plugin. Search for Kubernetes and you will get your this Kubernetes plugin. Just select this also and install these three plugins. So install, and these will get installed very fastly. Okay, success, 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 success. Okay, it is installing. Make sure all the things are in success, then only move ahead. Okay, so all the things are then success. Now we have to restart our Jenkins now. So just go on the VM instances SSH terminal. Let me clear this, and you will write here Docker restart and whatever your container name is. Let's give it Jenkins. Why we are restarting? Because we have installed some things in the Jenkins, right? So we have to restart it for so that we don't get any error in moving forward. Okay, so just press enter. So you will get a message Jenkins like this. And if you refresh your Jenkins here, and it will ask you to sign in again. It is taking time because it is restarting our Jenkins container. Wait. Hmm. So you can see it is giving us the message in the above starting Jenkins. Okay, Jenkins is getting ready to work. So it is asking for us the username and password that you set up. Okay, so I have already saved those. So I will select keep me signed in and sign in. Now you are on the dashboard again. Okay, now we have to do one more thing. Just open your VM instance now, your terminal. You have to go inside your Docker container, sorry, your Jenkins container, and you have to install some things inside your Jenkins container. What things you want? Basically, you want to install Python. You want to install your VENV virtual environment. You have to install your pip. By using that, you can install all your packages and all. Okay. So if you have done project 1 and 2, I think you are pretty sure what I'm talking about. So don't worry, I have given the code. You don't have to write it. Okay. Just go on the notepad file and just copy these command line by line. First of all, Docker execute Jenkins. Make sure this should be your container name. In my case, it is Jenkins only. So I will move forward. Control. Okay. Control C. So it will it will go inside your Jenkins container and open it in bash. So go here and paste it. You can see now you are inside your Jenkins container. Now copy these commands one by one. Just copy the first command. It will update all your packages. Paste. So it is updating. Let me copy my second command till then. It will basically install my Python. The second command will install my Python. So let's paste it here. Press enter.
Okay, now let's check whether Python is installed or not. Control C. So it will check our Python version. So it is showing us Python 3.11.2. So it means Python is installed. Now there is an issue. Okay, basically when you generally write your anything, you just write Python application.py, Python src training pipeline.py. You don't write Python 3. You don't write Python 3 application.py. Okay, to fix that, so that our Python 3 can be called as Python also, you will use this command. Because if you will see, if I am writing here Python hyphen hyphen version, okay, it is showing me Python command not found, because it is not recognizing. It is saying only Python 3 is installed, Python is not installed. But we want to make sure Python 3 is called as Python only. Okay, so I will copy this command. Okay, so it will make our Python 3 be treated as Python. Paste it, run it. Now if you will go and copy this Python version, I'm not writing Python 3. Now I'm writing Python version only. So if I will paste here, you are getting Python 3.11.2, same as your Python 3 version. You are getting the same output for your Python version also now. Okay, so that's a good news. It is not zooming. I don't know why. When there is some amount of code here inside this SSH terminal, it is not able to zoom out and zoom in. I don't know why it is doing that. Okay. Then after that, you will copy this command. It will basically install your pip package so that you can install all your dependencies. Okay. Just go and paste it here. Apt install pip. Okay. It will install your pip. Then your last command is to install your virtual environment package so that you can create your virtual environment. Copy it, then paste it here. Once your pip is installed, your virtual environment will get installed. After that, exit your terminal. You have installed all the things. Now you don't need to install anything. Just exit. Okay. Then you will restart your container again, your Jenkins container again, because you have made changes. Okay. You have installed Python, you have installed pip, you have installed VENV and all the things. Okay. So you will write Docker restart Jenkins. Okay. Just press enter. Let me clear the screen. Okay. Okay. Let me open my Jenkins. Let's refresh it. Okay, so it is perfectly refreshing, I think. Just move to the dashboard. Yeah, it is working fine. So with this, your all the Jenkins setup is done. Okay, you have done all the Jenkins setup. Now you will not face any problem with your Jenkins. Okay, your Jenkins is properly configured and all. Okay, so this was for this video. Let's move to our next video. Hello everyone. So in the previous video, you have set up your Jenkins. Now in this video, you will be integrating your GitHub with your Jenkins so that you can extract your all the code from there to your Jenkins. Okay. So first of all, what you will do, just open your GitHub. Okay. And go on your profile. Open your settings in a different tab. I will say in the different tab. Why? Because you will require that tab in future also. Okay. Just go below in the developer settings and go in the personal access tokens. Basically, personal access tokens gives you access to your GitHub repos. Okay, so Jenkins requires a token so that it can access your GitHub. So I will generate a new token. Let's create a classic token. Okay, just do the password and all. Okay, just give your password. Okay, you can give it any name. I'm giving it GitHub token only. Okay, now you have to give some permissions to it. First of all, repo permission. Okay, then workflow permission. Okay, then admin org permission, admin public key permission. Okay, admin repo hook permission, admin org hook permission. So these are your 6 permission. Let me again tell you: repo, workflow, admin, org, admin public key, admin repo hook, admin org hook. Okay, just generate the token and keep this page here only. Don't touch this page. Okay, don't touch this web page. So this is your access token now. Okay, go on to your Jenkins dashboard, go in the manage Jenkins and go in the credentials, go in the global, go in the add credential. Okay, and username will be your GitHub username. Okay, in my case, my GitHub username is this data guru 0. So I will give data guru 0. In the password, you will copy this access tokens and paste this. And I'm again telling you, please don't close this access token page. We require it again and again. And you can give it any ID. Okay, you can give it any ID. Let's give it ID GitHub token. Okay, just Control A C and paste the same in the description. Let's create it. And you have got your GitHub token in your credentials. Okay, so that's good. Now go again to your dashboard, Jenkins dashboard. Click on the new item. Okay, create an item name. Let's make a GitOps project. You can give it any name and make sure you select pipeline here. Okay, you have to select pipeline and just click on OK. Done. So you have created your pipeline. Now go below. Once you created the pipeline, go below. In the pipeline section, you will get the definition. So in the definition, you will select pipeline script from SCM. Okay, you will be selecting a script from SCM. SCM means your source code management. In our case, our GitHub is our SCM. So your SCM will be Git. Okay, and it will ask for your repository URL. So just go to your project and just go in the code section, and this is your repository URL. Just copy it and paste it here. In the credentials, pass your credential that you just saved, your GitHub token. Okay, and in the branch, in our case, our branch is main. Your can be master. Okay, so you can see mine is main here. So whatever branch you have, just pass it here. I am giving it main. Okay, and keep it this only. This is Jenkins file only. Just apply it. Okay, and save it. Done. Okay, now go to the pipeline syntax. Now in the pipeline syntax, in the sample step, select checkout. Okay, now pass the same things here. SCM will be your Git, repository URL you have passed. Okay, credentials, your GitHub token. Okay, branch, your main. Basically, it will generate a code so that you can connect your Jenkins with your GitHub, and all the things same. Just generate the script. So this is your code. Okay, so we require this code. Okay, so you have done this much. Now you have to create a Jenkins file. Okay, so let me come to my SSH cloud. You can see here, if I do ls, I don't have any Jenkins file here. Okay, I don't have any Jenkins file here, right? So what I can do, what we can do it from here also. So you will write vi. Okay, make sure your commands are correct. Just write vi and Jenkins file, and make sure your spelling is correct for Jenkins file. Z capital ENKINS. Okay, Jenkins, then FILE. Okay, press enter. So you have got this empty screen. Now what you will do, whatever you have got the code here. Okay, just copy this. Okay, copy this, and I have given you a notepad file in the resource section. Just this is your Jenkins code. Inside the Jenkins code, you have got this code, right? Now what you will do, basically below this echo, where you have got checking out from GitHub, just go below this. Okay, just go below, exactly below echo, and paste your this command, this checkout command. Okay, now what you will do next, just copy this whole, copy this, and here in the VM instance, paste VM instance, paste it. Okay, once you have pasted your code, what you will do, you have to press, let me tell you, you will press colon, you will press colon WQ. Okay, you can see here colon WQ and exclamation mark. Make sure it is correct. Colon WQ exclamation mark. Press enter. Okay, so what this colon WQ exclamation mark does, it will save your Jenkins file. Now you can see, I will do ls, and you can see your Jenkins file here now. Okay, so why I have done this, why I pasted my code in this notepad only, why just I didn't, why just I did this in the Jenkins file only, okay, that terminal only, because many people are not able to do that. Okay, for Mac users it is easy, but I don't know why, but there is a lag. Okay, so there is a typing lag in the VM instances terminals, so that's why I don't recommend these VM instances terminals. These are very laggy. Okay, so now we have created our Jenkins file now. Okay, we have saved it. Now what you will do, you will connect your GitHub repo now. Okay, let me clear the screen. How you will connect your GitHub repo? First of all, you have to do git, you will write the command git config. You have to configure it, you have to configure your git. So you will write git config hyphen hyphen global. Okay, git config hyphen hyphen global user dot email, and you will pass your email here. Okay, so I am giving it gyro, so it is my email, gyro god non @gmail.com. Okay, so just give it your email. Now same thing, just write git config hyphen hyphen global, okay, user dot name. Just give your name, anything. So I will give it data guru. Okay, inside the your double quotes. Okay, just press enter. Okay, now you will write git add full stop. Okay, done. So it will add all your things. Then you will write git commit hyphen m, and just write any message. I am writing the commit message only. Okay, so it will be committing these. Okay, then you will write git push origin to main. Okay, now it will ask for your username. What is your GitHub username? You will pass here. Mine is data guru 0. Press enter. Now it will ask for your password. Now just go to your browser, and whatever personal access token you have generated, just copy it. Okay, and open your SSH terminal. Right click here and paste it. Okay, you will not see anything here. Just paste it and press enter. Okay, so it will automatically push. You will not see here for your security purposes, right? So it is showing us large file detected and all, but it's not necessary. So if you go to your now GitHub, just refresh it. you can see now your Jenkins file is there. Okay, so now you can see your Jenkins file is there, perfectly fine and all. Okay, your manifest and everything is there, everything. Okay, so now what you will do, uh, there are some unnecessary files also here. You can see this kubectl sha 256 kubectl. Okay, but we can ignore this for this project. We can ignore this. They are not making any harm to our project. Okay, although it's a bit big, it is around I think 4950 MB, but our Git can handle. Okay, this much big file our Git can handle. So no need to make any changes to these file. Now just go to your Jenkins dashboard. Okay, and open your pipeline, that is your GitOps project, and just build it. Okay, because now we have our Jenkins file. Now you can see in our GitHub repo we have our Jenkins file, and we have our first stage also. Our first stage is check out GitHub, and we have pasted our code, right? So you can see our now first pipeline is getting built. In the console output you can see there is a green tick, so our pipeline was a success. Okay, so now you can get there is a success message. If you want to see, you go in the workspaces. Okay, in the workspaces here, click on this link, and you can see all the things are copied from your GitHub. All the things that are in your GitHub now are in your Jenkins workspace. Okay, so it means you have successfully integrated your GitHub with your Jenkins. You have done this before. Okay, but in project 1 and project 2 you have done it on local machine, but now you are doing on a cloud machine, that is your VM machine, right? So okay, so this was it for this video. Now let's move to our next excitement. Sorry, I didn't get any punchline. Hello everyone. So in the previous video, you have integrated your Jenkins with your GitHub. In this video, we will be building our Docker image and pushing that image to our Docker Hub. Okay. So for this, what you will be doing basically, first of all, just go to your Jenkins dashboard. Basically, we have to set up some tools. Okay, just go on the manage Jenkins. Okay, just go on the tools. Okay, here is a tools option, and just go below and your Docker installation. Basically, for building and pushing image we need Docker, right? So we will add Docker. Okay, and since we are doing our CI part, that is our integration part using Jenkins. Okay, just give it any name. I am giving it Docker. Okay, and just select this install automatically, and then add installer, and just select download from docker.com. Okay, just select the latest only, that is by default. Just apply and save. Okay, so it is done. Okay, now your Docker is installed on your Jenkins perfectly. Now you know code is good to write on VS Code. We can't write the code again and again on the terminal, right? It's a bit hectic. Okay, so what I will do, let me clear my VS Code terminal, and what I will do basically, just pull all the code from my GitHub. So I will do git pull origin to main, press enter. So it will pull all my code. Okay, so it has pulled all the code. Done. Now your VS Code is updated with your GitHub repo. Okay, previously your VS Code was behind your GitHub repo because some things were added from the terminal only, were not added from VS Code. Okay, but now we have extracted the pulled the code, pulled all the contents from the GitHub repo. Now our VS Code is synced with our repo, right? I, I think you understand what I'm saying. Okay, Uh, let me clear the terminal, right? Now, since we have done this, let me open the browser and just open the browser and search for Docker Hub. Okay,
because basically here we will be storing our images, right? So just make an account on Docker Hub, just sign in there, and once you have done, that's good. Just create a repository. Okay, you will get option to create a repository. Let's name our repository as uh, GitOps project, right? And let's make it public only. You can give description. Let's create it. So we have got our GitOps project repository. That is our Docker Hub repository. Basically, here we will get our images. Pushed images appear here. You can see, but since we have not pushed any, okay. Now, what you will do? You need a token for your Docker Hub also. So what you will do? Just go to your Docker Hub profile. Okay, just open account settings in a new tab. Okay, just open the account settings in new tab and just go to the personal access tokens and generate a new token and just give it any name. GitHub token Docker Hub. I am giving it GitOps project. Okay, expiration date you can set it any. I am setting it none. In the permission, make sure you select read, write and delete. Okay, just generate it. So you have got this. Make sure this page is open only. Okay, now go to your Jenkins and just go to the manage Jenkins. Okay, suppose you are in the dashboard and just go to the manage Jenkins now, and you have to add credentials for Docker Hub also. So go to the credentials and you will get option here global. Click on the global, add credential, same. Okay, in the name section you will pass your Docker Hub username. So your Docker Hub username is this dataguru 97, whatever you will get here. Just paste it here. In the password, just copy this access token and paste it here. And ID, you can give it anything. So I am giving it GitOps Docker Hub token. So copy it and paste the description as same also. Okay, just create it. Not now. Okay, so you have got your GitOps Docker Hub token also here. Done. Now what you have to do, you have to make the code for your building image and pushing image. So that we will be doing in our VS Code, of course. So let me close the terminal for now and open my Jenkins file. Okay, so you can let me fix the indentation here. Although it's working fine, but let's fix it. First of all, what you will do, first of all, you will define some environments variable. Okay, you will define some environment variable. So you will go below this agent any. Okay, just go below this agent any. You will write in y run meant. Okay, like this. Press space, curly brackets, press enter. Now you will give two environments. First of all, Docker Hub repo equal to, then your another one is Docker Hub uh, credentials ID. Okay, now in the Docker Hub repo, you will give your Docker Hub repo. Okay, so just go in your Docker Hub. Okay, just copy this dataguru 97 and GitOps project. Copy this and paste it here. Okay, one more thing, go in your manifest, go in your deployment and paste the same thing here, dataguru 97 GitOps project. Just place latest at the end. Okay, just place GitOps project latest at the end. Make sure you do this. Okay, then the Docker Hub credentials, just go here and go in the Jenkins, whatever name you have given here, that is your GitOps Docker Hub token. Just copy this name and paste it here. Okay, so you have set up your Docker Hub repo environment ID and Docker Hub credential ID environment. Okay, now you are moving to your build Docker image stage. Okay, you will be building your Docker Hub. So just go in, let me remove this. So let me cut this. Okay, what I will do, just go inside the steps. Inside steps, you will write script. Okay, inside script, you will do curly brackets. Go inside this curly bracket. Now what you will write, first of all, do the echo message. Okay, now after echo message, let me define a variable. Let's name it Docker image, like this. Okay, and you will build your image docker dot build. Okay, now what your image name will be, just give a bracket here. Okay, just give quotes here, double quotes, and just give your environment variable. For giving environment variable, you will give dollar sign. Okay, inside dollar sign, you will give your Docker Hub repo. Basically, let me copy this so that I avoid any typing mistakes. Just copy this and paste it. Okay, just give it Docker Hub repo. And after repo, just give here latest. Okay, so that you will get a image data guru 97 GitOps project latest, and I have given the same file here, data guru 97 GitOps project latest. Okay, so that's why. Okay, so now you have built your image. Simple code. Now you have built your image. Now let's push it. For pushing, same thing. I will remove this echo message, cut this message, go inside the steps. I will write here script. Okay, for pushing image, I will write the echo message first. Okay, then what you will write? You will write docker dot with registry, registry. Okay, in the registry, what you will pass, basically, you will pass your Docker Hub registry. So your Docker Hub registry is like this: https. Okay, https colon / registry, make sure your spelling is correct, registry dot hub dot docker dot com, like this. Okay, then you will place a comma here. Okay, you will be accessing this registry using your credential ID. And what is your credential ID? Give a colon, quotes here. Your credential ID is inside this Docker Hub credential environment. Okay, so copy it and just give a dollar sign here. Okay, just give a dollar sign here, give curly brackets and paste your Docker Hub credential ID inside this. Okay, done. After you have done this, just give curly brackets again and press enter. Press enter. What it is doing? Okay, now you will be writing code inside these curly brackets. Now you are inside this Docker registry. So for pushing the image, what you will write, which image you want to push? You want to push this image, your Docker image, because your Docker image is inside this variable. So let's copy this Docker image. Okay, Docker image dot push, and we want to push the latest image. So I will give here latest. Okay, so this was your all the code for building and pushing. Okay, we will come to our installing ArgoCD kubectl part also later, but for now this is our build and push video, right? So for building, we use docker.build, and then for pushing, first of all we connected with our Docker Hub using our token, then we pushed our image, right? So let's save this, and we have also made changes to our deployment.yaml also. Okay, so make sure you give the
image name according to your project. I have already explained, right? Whatever your Docker Hub repo name is, just paste it in the deployment, and after that give a colon latest. Okay, let me open my terminal here. Okay, just do your git add, git commit, and git push. Done. You can check whether things are updated or not. Let's do this, and let's check our Jenkins file, and you can see the codes are updated. We have got our build code. You can see docker image docker.build. You have got your pushed image. You have got all this, right? Now just go to your Jenkins, go to your dashboard. Okay, just go to your pipeline, and let's build our pipeline. Let's see whether we get any error or not. Hope so we don't get any error. Let me open the console output so that we can see. Okay, just go below, and you can see it is building our image. Our building has been started. You can see building Docker image. Okay, and our building has been started. It is moving step by step. That our work directory, then copying all the contents, all the steps that you defined in your Docker file. Okay, let's wait for it to get completed. After that, we will come here. Okay, so after some time, our building and pushing have been completed, and we have got the success message. Okay, so you can see we have got the success message after pushing our images and all. Okay, so it is basically logging into our Docker Hub so that it can push the image. Okay, and it is logging in using our access token, Docker Hub access token. Okay, so with this, your building and pushing stage is also completed. Let's move to our next video. Hello everyone. So in the previous video, you have done the Docker push and building your image part. In this video, the main part will start, and this is a bit tricky video, so make sure you follow each step clearly. Okay, so basically in this you will be setting up your ArgoCD, okay, for your VM instance, okay, for the deployment part basically. Okay, because we have done CI part, right? We have built our images and pushed that to Docker Hub. Now comes the CD part, but before doing the CD part, we need to configure our ArgoCD, right? So let me close these unwanted web pages, okay, because we don't need this, right? We also don't want Docker Hub now, right? Okay, let's keep it. Now let me open my terminal, SSH terminal. Let me clear it. Okay, so first of all, what you will do, you will write one command. Since you have installed kubectl, right? So you will write kubectl get name space. Okay, press enter, and you will see you have got some kubectl namespaces here. One is default, you have node lease, public, system. You have to create one namespace for your ArgoCD. Okay, so how you will create? You will create using kubectl create ns, ns means namespace, and give it ArgoCD. Okay, in small ArgoCD. Okay, now let's use the same command again, get namespace, and you will see now ArgoCD namespace is there, which we have activated just 7 seconds ago. Okay, okay, now we have to install ArgoCD all files. So I have given the code in notepad file, so you will just copy this code first of all, your first one, kubectl apply and https raw github user. Okay, just copy this, just copy this and paste it in your VM instance, press enter. Okay, so it is installing your ArgoCD all the files. Okay, Okay, after you have installed, let me clear the screen so that you can see the code clearly. Okay, now you will write kubectl get all -n and whatever your namespace was. I have named it ArgoCD only, right? Oh, I did mistake. Get all -n and ArgoCD, whatever your namespace was there, right? Press enter, and you will see all are in running state. And make sure these all are in running state, only then you proceed. Okay, if these are not, please don't proceed. Okay, make sure these are all in the running state first. Okay, let me do it again. And now you can see my previous one was not in the running state, it was 0 by 1. Okay, now it is all 1 by 1, 1 by 1, 1 by 1. Okay, then it is good to proceed now. Let me clear the screen. Okay, now you have got the green signal to proceed ahead. Now what you will do, you have to check the services for your ArgoCD namespace. So you will write kubectl get svc. Svc means services. Okay, -n and your namespace, that is your ArgoCD. Press enter, and you will see your ArgoCD server. Okay, your ArgoCD server is a cluster IP. You can see your ArgoCD server is a cluster IP. Okay, we have to convert this cluster IP into a node port. Why? What is the difference between a cluster IP and a node port? Basically, a cluster IP can be accessed only internally, but a node port can be accessed externally also, right? So that's the main difference. Okay, so now you have got the difference between what is cluster IP and ArgoCD. Okay, so internal, external is the difference only. So we have to edit it. Okay, we have to edit our ArgoCD server. So let me clear it. Okay, so how to edit it? You will write kubectl edit svc. It means edit service. And what is your service name? It was ArgoCD server. Okay, that was the service name, right? -n, and what was your namespace name? ArgoCD. Whenever you write -n, it means you have to specify your namespace name, and our namespace was ArgoCD. So press enter. So now you have got your this ArgoCD configuration file. You have to go below. Okay, below. Okay, and just go below. Okay, search for this cluster IP. Okay, you have got this cluster IP now. You have to delete it. Okay, just delete it, delete it, delete it, delete it, delete it, delete it. Okay, okay, why I'm not able to write it here? I don't know. That's why there is a problem in writing here. Why it's not writing? Mm, okay, now it's writing. I don't know what issue they have. Okay, make sure there is a space after type. Then you will write node port. Okay, NODEPORT. Make sure spelling is correct. N capital and port capital. Okay, node port N capital, P capital. Then you will press Control C. Okay, then same. You will pass colon. Okay, WQ and exclamation mark to save the file. Press enter. Now your file is edited. You can see you will get the message service ArgoCD server edited. Okay, so it means you have successfully edited your server file. Okay, ArgoCD server file. You have created it from cluster IP to your node port. Now to see it, you will just go there and just run this command kubectl get services -n ArgoCD that you already ran before. Just press enter. Now you will see Now ArgoCD server is a node port instead of a cluster IP. So it means you have perfectly edited it. Let me clear. Okay, so you have done this. Now you have to run one command I have given in the notepad. Okay, this kubectl port forward service ArgoCD server and 31704, and make sure, let me go here and just write kubectl get svc -n and make sure this is your number 30751. Okay, okay, whatever the node port number is, like in my case this is 30751, you can see. So make sure you write the same number here, 30751. Okay, in the second command 30751 and port will be 80 only. Okay, so let me again check, 30751 and it is 30751. Okay, so just copy this, and whatever your namespace name is, make sure you write this. My namespace name is ArgoCD only. Okay, so just copy this. But the what this command will do, basically it will jam your this terminal. You can't use this terminal again. Okay, so what you will do, you will create one another terminal afterwards. So just paste it here, your kubectl port forward command, and press enter. Okay, so it is forwarding to 8080. Okay, so let's see now. Just go to your browser and go to your VM instance. Okay, now what you will do, basically copy the public IP. It means your external IP of your VM machine. Just copy it, give a new tab, paste it here, write a colon and give the same name. What was that? Give the same port, sorry, 30751. So I will give 30751. Press enter. So it is showing your connection isn't private. Go to the advanced and continue anyway. Although it is unsafe, just continue. So you will see your ArgoCD dashboard. Okay. But now you need username, you need password. Username is admin. By default, username is admin. Now to get password, what you have to do, basically, first of all, let's create one more SSH terminal, because you can't use this terminal now. Okay, because it is handling connections here for ArgoCD, so you can't use this now. So go to your VM and just go here and connect another SSH terminal. Okay, so this is our new terminal here. So let's connect it. So it is taking times to connect. You will authorize it. Authorize. Okay, so I will give it command ls and I will go inside my GitOps project 9. So you will write cd, whatever your project is, GitOps project 9. Okay, just go here. Now I am inside my GitOps project 9. Let me clear the terminal. Okay, now what you will be doing, you know your admin username is admin, but now you want password. So how you will get password? So there is another command. Just go to notepad. I have given this command kubectl get secret -n argocd. So this will be your namespace name. Make sure your namespace name is correct. Then argocd initial secret password, and it will decode your base 64. Basically the password initially is in base 64 format. We will decode it to get the real password. Okay, so copy it, go to your new terminal and paste this command there. Make sure you correct your namespace name. My namespace name is ArgoCD only. So press enter. So here you can see you will get a password like thing. Okay, so this is your password. Just copy it. Okay, and just go to your ArgoCD UI. Username is admin, and just paste your password here and sign in. Okay, So now you are on your ArgoCD dashboard. Congrats, bro. Okay. Now you have logged in into your ArgoCD UI. So this is your UI. You have your application settings, user info, documentation, and all. Okay. Till now it was easy. Now comes the tricky part. Okay. Now how you will do basically, just go to your VM instance. Okay, new VM instance basically. Let me clear this. What you will do, you will go to the root. Okay. Now you are inside this GitOps project 9, but now you want to go to the root. That is your gyro god non @GitOps machine. So how you will go to the root? You will write cd full stop full stop. Okay. Now you are in the root. Now you are outside the GitOps project 9. Okay. You will write ls -la. So it will show you all the files in the root. So you can see one of your file is here .cube. Okay. Your one file is .cube. Basically, this file has all the configuration of your Kubernetes. Okay, you have to edit this. You have to edit this and modify it according to your need. Okay, so how you will do it? Uh, basically, first of all, you will go and check what files are inside it. So you will write ls -la. Okay, I think it is maximite, right? ls -la .cube. Your file name is .cube, right? And go inside this .cube. You will see it has two files, basically catch and config. So our main concern is with the configurations. So we will be going with the config files. Okay. So I want to see the contents of this config file. So you will write cat, okay, .cube. Inside .cube I want config. Okay. Inside .cube I want the config. So just press enter and let me minimize it, and you will see all the contents of your cat.cube config. Okay, so just copy these, copy this, control C. Okay, you have copied it. Now what you will do, just open a new notepad tab and paste it here. Okay, now what you will do, basically you will edit something. You can see here it is ca.crt, client.crt, client.key. Instead of giving paths, you can see these are your file paths. Okay, home, gyro god non dot minikube. Instead of giving paths, we will directly pass data here. Okay, so I will change the variable names from certificate authority to certificate authority data. Okay, client certificate to client certificate data, client key to client key data. Okay, done this much. Good. Now come again to your, okay, uh, unhandled error. I don't know. Our Argo CD is closed. No, it is working. So it means the error is not of our concern. Okay. Now let me clear the terminal. Okay. Now what you will do basically, since you have edited three names, okay, certificate authority data, client key data. Good. Now you have to edit their contents. Instead of paths, you will pass the contents here directly. Okay. So first of all, you will copy this path, home gyrogod.minikube.ca.crt. Copied, done. Just open your VM instance. Open. Now what you will do basically, you will convert this file path into a base 64 format. Okay. So you will write cat. Okay. Just paste the path here now. Paste the path. After that, give a straight slash. That is your this. Then you will write base 64 space -w. Okay. Then 0. Okay. Then semicolon. Then echo. So this is your command, cat, whatever the path is there, paste it. straight slash base 64 hyphen w 0 and semicolon space echo. Okay, press enter. So it is giving me some base encoded code something. So let me copy this. Okay, till double equal to. Okay, copy it, go in the notepad, remove this. Okay, now remove this and paste your code here like this. Paste it. Okay, now the next we have to do with client certificate data. So copy this. Okay, copied the path. Now go to your this, write the same thing, cat, paste the data, sorry, paste the path, then straight slash base 64 hyphen w 0 semicolon space echo. Press enter. It is again giving me some code. I will copy it till double equal to. Make sure you don't add any space. Okay, till double equal to. Copy it, and in place of this, I will remove this path now, and in place of this, I will paste this. Done. Now copy my last part, that is your client key data. Okay, just copy it, and do the same with this also. Let me clear the screen. I will write cat and paste the path here, then straight slash. Okay, after straight slash, I will write base 64 hyphen w 0 semicolon echo. Press enter. Okay, so it has given me, this is a bit big file. Okay, so I will maximize my screen, and now copy it till equal to. Copy it. Now I will minimize it again, and in the notepad I will remove this part and paste my this. Done. You have got the notepad file. Now keep it as it is. Okay, don't save it or anything, just keep it as it is. Now what you will do basically, because if you saved it here, it will be in txt format. We don't want it in txt format, we want it in system format. Okay, because system formats are the file that are made for your systems. Okay, for system configurations, we don't want txt file, right? So what you will do basically, just open your git bash. Okay, it needs a git bash terminal. So if you have not installed, just go to the browser. Okay, and just install your git cli. Basically git bash is automatically installed as soon as you install your git cli. Okay, so install your git cli, and once you have installed, just open your git bash. Okay, I have opened it here, right? Let's go in the downloads folder. Okay, so I will write here cd downloads. Okay, so now I am inside my downloads folder. Okay, so what you will be doing here, let me remove my previous download folders files. Okay, so there are already some files. Let me remove these config and configuration file. Okay, we will create one new. Okay, let me remove these. Okay, now we don't have any. Now what you will do basically, you will write here vi. Okay, you will write here vi cube config. Okay, you will write vi cube config. Make sure spelling is correct, right? Vi cube config. Okay, so it will basically create one cube config system file. Press enter. So it will ask you to write the code. Okay, so now just copy the all the code for your from your notepad. Just Control A and Control C. Okay, just go on your git bash and here paste. Okay, after the pasting, you will press Control C, and after you have pressed Control C, just write the same thing. colon WQ and exclamation mark, enter. So it has basically saved your kube config. Now you can close your git bash terminal. If you will see your downloads, okay, you have got your kube config file. You can see if I will check its properties, and if I go on the details, uh, it's a type file. Basically it is a system file. If I have saved it in notepad, it will be of .txt file. Okay, right? So we have got our kube config file, so it will be needed. Okay, basically this will be our configuration file for our Kubernetes. So keep it here only, we will be uploading that file later. Now come to your here in the terminal. Let me clear the terminal. Now what you will be doing basically, just open the Jenkins now. Open the Jenkins. Okay, just go to the dashboard. Okay, just open your this pipeline, go in the configured section. Here it is your configured section. Okay, and in the configure section, where you will go, okay, sorry, go in the dashboard. Sorry, in the manage Jenkins, I got confused. In the manage section, go with the credentials. Okay, go in the global and add credential. Sorry, I got bit confused. Okay, in the kind you will write secret file, because you will be uploading a file, right? So choose file, and you will upload this kube config file, okay, that you just made. Okay, so now it is kube config. If you have made it using notepad, it will be here kube config.txt. So make sure there is not no .txt, it should be only kube config. Okay, and let's give it id. Let's give it the id same, kube config, control AC, control V. Okay, so it will be your kube config. Okay, let's create it. So now we have three variables, our credentials, and it is our latest credential kube config. Okay, again coming to my description. Now just go to your pipeline. Okay, and go to the now the configure section. Okay, look for your pipeline syntax. Here below there is a pipeline syntax option. Just open it, it will open in the new tab basically. Okay, in the samples tab, search for Kubernetes. So just search for K. You will see here kube config. Okay, set up Kubernetes CLI. Select it, and basically it will ask for your Kubernetes server endpoint. It will ask for Kubernetes server endpoint. Now, how you will get your server endpoint? Just go on your VM instance. Just search for kubectl cluster -info. Okay, and it will give you a Kubernetes control plane is running in this HTTPS 192 something. Okay, so just copy it. Okay, so copy it and just go to your Jenkins now and paste it here. Okay, in the server endpoint, we don't want any certificate, because basically all the certificates are inside our kube config only. So in the credentials, select your kube config, okay, which you just saved. Okay, and generate the script. You have got the script. Save it as it is. Okay, keep it here only. Okay, no need to change or make anything else. Okay, so save it here. Now what you will do basically, uh, let's move to our next video. Basically all the configurations are done for the Kubernetes. Now in the next video we will be making the code in our Jenkins file. Okay, so let's move to our next video, otherwise this video will be too long and maybe some will get confused and all. So till now we have configured our ArgoCD. Okay, and you have done till this step. Okay, so let's move to our next video now. Okay, so in the previous video, you have done till here. In this video, we will be installing ArgoCD and kubectl in our Docker container. Okay, in our Docker container. Okay, in our VM instance, they are already installed, but in the Docker container, they are not installed yet. Okay, so for this, what you will be doing, open your VS Code, open your Jenkins file. Let me close this terminal. Just go to this stage, that is your install kubectl and ArgoCD CLI. Okay, let me remove this echo part. Okay, what you will be doing basically, you will be writing in this kubectl and ArgoCD CLI sh. Okay, it means shell commands, and you will be giving multi-line commands. So just go and give triple quotes, press enter, give again triple quotes. Okay, now in between these triple quotes, you will be giving shell commands. So I have given the commands already in the notepad. Okay, so these are your commands, just copy them. Okay, these are your echo, installing, and kubectl argo cd cli. Just copy these. You can also find these commands in the Google also. Just search for how to install kubectl and argo cd cli. Okay, so some commands are for kubectl, some are for argo cd on your Docker container. So just paste them here. Okay, let's fix the indentation. Let's give them proper. Okay, instead of tab I print something else. Then here, then here, then here. Okay, then here. Okay, so we are using Argo CD Linux machine image, and same we are using here for kubectl. This much is for kubectl, you can see. Okay, and these last lines are for Argo CD installation. So with this, you will be able to install your Argo CD as well as your kubectl on your Docker container, where your app will be running, because it will require kubectl and Argo CD CLI, because you have to interact with your Argo CD for deployment purposes. Okay, so it is necessary to have a Argo CD CLI on your Docker container and kubectl also, to because we will be interacting with our minikube also, because minikube will be the platform where our project will be deployed. Okay, so done this much. Okay, so you have installed kubectl and Argo CD CLI on your Docker container. Now what to do next basically, uh, then our next stage is apply Kubernetes and sync app with Argo CD. We have to sync with our Argo CD, right? Now how you will sync with your Argo CD? Basically, you will do same thing here. I just, in the previous video, you generated this pipeline script, right? You generated this pipeline script. Okay, so now you will be using this pipeline script. How? Let me copy this pipeline script for now. Okay, let me copy this. What you will be doing, just remove this echo. In the steps, you will be writing script, because you will be passing the script commands. So inside script, just pass your this kubeconfig pipeline syntax that you just copied. Okay, so let's fix the indentation. Okay, so it is showing us some block. Inside the sum block, you will be writing something. So it is giving you the credential id kubeconfig that you uploaded. Your server url is this. Okay, and now let's remove this sum block comment. And once you come inside this kubeconfig, okay, now you are inside this kubeconfig. What you will do basically, you will write shell command sum. Okay, so since it will be a multi-line comment, just pass 3 blocks here, 3 quotes here, and it will be a perfect shell command. Okay, first of all, you will be logging into your Argo CD. Okay, you will be logging in into your Argo CD. For logging in, what you will be doing, I have give you the command. So you will be passing this command. Okay, this Argo CD login, whatever this is. Okay, so just copy this line.
Okay, till insecure, just copy it and paste it here. Okay, everything will remain same. Basically, your username is by default admin. Your password will be, you will get using this. Okay, you know we use this command kubectl get secret hyphen n argocd initial admin secret JSON path. Then we decoded it, and okay, you have used this command previously to extract your password for argocd login. So same we will be doing here. First of all, we will be doing login into our argocd. The only thing you have to change here is this URL. Okay, so just go there, go to your ArgoCD, make sure it is running. Okay, it is running. Just go here and copy this. Okay, copy this much, your IP till 34.69, something like this. Just copy this and replace here. Okay, 34.691 point and whatever your port is there. Okay, you have to just replace it. Okay, then you will write one more command here, and I will tell you the benefit of that command later. You will write argo cd. Since your argo cd is now installed in the above step, you have installed your argo cd CLI, right, in the previous stage. So now you can use argo cd commands. So you will write argo cd app sync. Now you have to sync your argo cd with your app name. uh, just give any app name, but make sure you give the same app name during app creation. Okay, so I will be giving it GitOps app. Okay, I will tell you when I will make the app, you have to give the same name. Okay, just save this. Okay, only you have to do this much. Okay, you have done this much. You have created basically two stage. First of all, you have installed your kubectl and argo cd CLI. Then you have applied your Kubernetes and sync it with your argo cd app. Okay, only this much is needed. You have got to know how you will do this, right? Good. Okay, so this was it for this video. We will be pushing the code later. Okay, you don't need to push the code now only. We will be pushing code later. Don't worry, everything will be pushed. Everything. In this video, basically we did all the coding part only. Okay, now everything will be just button clicks and little bit of small syntaxes. Okay, so let's move to our next video. Where we will be doing the setup on our Argo CD app. Okay, we will be creating our Argo CD app basically. Okay, and that app name will be our GitOps app. So remember that. Okay, so let's go. Okay, so hello everyone. So in this video, we will be making our Argo CD app. Previous video, you have done all the Jenkins coding and all. Okay, so you have created, you have built overall your Jenkins code, right? Now just only small processes are remaining. Just go to your browser, just go to your Argo CD whether it is working fine or not. Okay, so it is working fine. Sometime it gets crashed if your this terminal stop working. Okay, so you have to restart this terminal. Okay, first of all, go in the settings. Okay, and in the repositories, you will go in the repositories and just go to connect repo, and inside this via SSH you will write via HTTPS. Okay, type will be your git. Okay, name you can give anything. Let me give it GitHub. Okay, let's give it anything. Okay, project, go with the default repository URL. Yeah, just go here and just go to your GitOps project 9 and go in the code and copy this HTTPS URL. Copy it in the Argo CD, paste this URL. Username, although it's optional, let's pass our GitHub username, data guru 0, whatever your username is. In the password, pass the personal access token of your GitHub. Okay, that's why I said to open, make sure this tab is open throughout. So copy your GitHub token and paste it here. Okay, TLS certificate, we don't want. All other things are optional. And then we have server verification, proxy. Okay, we don't want this. Okay, now what you will do, there is a connect button. Just click on this connect. Okay, not now.
So you will get a successful message. If you are getting this message, good, you have successfully connected to your GitHub repository. Okay, fine. Now go in the ArgoCD, there is a option applications. Go in the applications. Now create a new app. Okay, give any name to application. Let's name it GitOps. Okay, you can't make it capitalized, you have to make it small. So GitOps app, and this name is same as your VS Code and ArgoCD app sync GitOps app. Okay, so make sure whatever name you write in your Jenkins file, just copy the same name here and paste the same name in the application, that is your GitOps app. Project name default. Okay, sync policy automatic, and let's take this prune heal and sorry, prune resources and self heal. Okay, and just go below the source, the repository URL. So you have to select your repository that you just saved. Okay, that is your GitOps project 9. Then in the revision, what is the meaning of revision? Revision means your branch name. So just remove, cut this, and you will get option main, because your GitHub is in main branch. So select main from here. Okay, leave the path as it is. Okay, then what you will do, in path. Okay, in path we need, just go here, and this manifest is your path, because manifest has your Kubernetes deployment files. It has your deployment and it has your service YAML file. Okay, so just pass manifests here. You will pass here manifests like this. Make sure your spelling is correct, right? Manifests, manifests, right? Good. Okay, now cluster URL, you will select the by default URL, that is Kubernetes default.svc. Okay, and in the namespace you will give your namespace, that is your ArgoCD. This is the namespace you created in your ArgoCD configuration video, right? So you will pass the same namespace here. Then a directory, we don't want these, so leave it is as it is. So I'm telling you again, application name same as your Jenkins files name. Okay, whatever you give the name in Jenkins file, ArgoCD app sync, whatever name was there, give the same name. Default, automatic, tick these two options. Okay, choose your GitHub URL. Revision, it will be your main branch. Path will be your where is your deployment and service file are there, in which folder. So that's why we have given manifests. Then select the destination, the by default cluster URL, and give the namespace ArgoCD. Okay, where your ArgoCD is running. Okay, done all the things, just create it. Okay, so just create it, it will take some time. Let's open it. Okay, so you can see the workflow of your ArgoCD app. We have one GitOps app, then you have one your, this is your deployment file. Your deployment file was name was MLOPS app. Then there was a service file. This is your my service file. Okay, then at the end it has created two pods. Basically it has your two replicas. In the deployment file you configured that we want two replicas, so at the end you are getting these two replicas. So this is the workflow of your CD, continuous deployment, like how it will work. Okay, so it is it has synced successfully. Now it is checking the app health. So wait till you get here healthy. You will get a healthy message here. Okay, once you get a healthy message here, uh, you can proceed ahead. Okay, so let's wait till we get a healthy message. It is progressing. uh, Basically it is here and you are getting a message healthy. Okay, so it means your app is healthy and perfectly synced, and now you can move ahead. Okay, and make sure, I'm again and again telling, uh, this name should be same as your ArgoCD app. Please don't make this mistake. Okay, this is important, right? Now what you will do, just go to the Jenkins. Now go to your Jenkins dashboard, GitOps project. Okay,
and just build your pipeline. Now you will, okay, no, don't build. We have not pushed code yet. Okay, so our Jenkins file is not updated. Just go to the VS Code and open the terminal, save these, and just do git add, git commit, and git push. Okay, so our Jenkins file will get updated because it is getting the code from GitHub, and in the GitHub our file was not updated, right? Now you can build. Okay, now you can build. So make sure you update your code in the GitHub also. Okay, so here is our console output. Let's wait till this pipeline get executed thoroughly. Okay, after that the main part will start. Okay, first of all you should get a success message here, then only you can proceed to next stages. Let's wait till our whole pipeline get executed. After that I will tell you. Okay, so now you can see our pipeline was a success. Okay, you can see your these stages. These were your installing kubectl and ArgoCD CLI. It has installed successfully. Then it was logging into our ArgoCD and all. Okay, and if you check your ArgoCD, if I refresh it, okay, it will show you. It was basically in ArgoCD you have two syncs. Basically, one is your current sync, one is your previous sync that was healthy. So our previous sync was healthy a few seconds ago. Okay, so our previous sync was perfectly fine because our pipeline was perfect. Okay, now your pods are also green, so it means your pods are also running. Now you can access them. You can see these are running. You can see if I zoom out, these are running. If I zoom in, sorry. Okay, if you can go in the logs, you will see here these are running. Your Flask application runs like this only, right? So let me cancel these. It means they are running. Now how to access them? Okay, you can access them using, just copy them and paste on the Google, and your Flask run on 5000 port. So write 5000, press enter. It will not run. Okay, why will it will not run? Let me cancel this. Uh, there is a reason. Let me clear the terminal first. Okay, there is a reason. The reason is that is your minikube is running inside the VM instance. Okay, so your minikube can be accessed only internally. It can't be accessed externally. Okay, to access it externally, you have to make minikube accessible from internet sources also. Okay, right? You are understanding my point, right? So how you will do that? Basically, first of all, let's check. You will write kubectl, okay, get deploy -n, and your namespace was ArgoCD, right? Like this. Okay, so you can see your MLOps app is running. This was your deployment, right? You created in your Kubernetes deployment files. And why it is 2 by 2? Because there are two pods running. Okay, and it is up to date. It is available also, and it was created 6 minutes ago, right? So it means it is running. Okay, if you want to check them separately, what you can do here, you can write kubectl, okay, get pods, since these are pods, -n argo cd, right? Press enter. You can see these are your two pods. This one is your first pod and this one is your second pod, and both are in running stage. It means they are perfectly working. Okay, still we are not able to access them, and I have already told you the reason. Because minikube is working internally, so you can only access them internally. You can't access them externally, but we want to access them externally, right? Otherwise how will other person will access our app, right? So to access them externally, which command you will write? You will write mini cube kernel. Okay, this command will make your minikube externally available. Press enter. Okay, but the disadvantage of this command is now you will not be able to use this SSH terminal. So let's close this. Oh, just minimize it, not close. Okay, just you have to open another terminal. So go to your VM instance and open another terminal. You have to authorize it and all the processes, right? Okay, so still you are not able to access. Okay, although you have done the tunnel command, still you have given the permission, but to access them you have to forward it to some port. Okay, so first of all, let's log in into our GitOps. So let's write ls and just to cd GitOps project 9. Okay, let me clear. Okay, now you are inside the GitOps project 9. Okay, now what you will write, basically make sure these two terminals are running. In first terminal your ArgoCD is running, second your minikube is externally available. Now how to access it, you will write kubectl port hyphen forward. Okay, make sure spelling is correct, FORWARD, right? Port forward SVC, that is your service is your my service. Okay, in Kubernetes deployment file you created service name as my service. Okay, in the VS Code, in the service.yml, you can check your service name was my service. Okay, so just go, where is my new terminal? Here. Okay, so my service, after my service you will give the namespace name hyphen n. Your namespace name was ArgoCD, right? ArgoCD hyphen hyphen address, ADDRESS. You will give the address. Our address will be accessible from any port, that is 0.0.0.0. It means everyone can access this. Okay, 0.0.0. On which port it will be accessible? We can't give it 8080 or 3170 like this, because 8080 is being used by Jenkins and 317 something is used by ArgoCD. So let's give it a new port, 9090. Okay, so I'm giving it 9090. Okay, so it has been shifted here. Let me maximize this terminal. Okay, 9090, you can see here 9090, then colon, okay, 1990, then colon 80, because 80 is the port where it is listening to, and 9090 it will be externally available. Okay, so just press enter now. So it is now forwarding. So let me minimize it. Now copy your external IP of your VM instance, paste it in the browser. Okay, semicolon 9090, whatever port you have given, press enter, and you can see your app is now accessible from internet. Okay, okay. Now there are still some things that we need to do. First of all, we need webhooks. Why we need webhooks? Basically, first of all, suppose I am using my VS Code, right? I have to push my code to GitHub. Then then I have to go to my Jenkins and I have to click on the build pipeline step. Okay, I have to go to my dashboard and I have to open my pipeline. Okay, then I have to click build pipeline. That is too much hectic. I want, as soon as I sorry, as soon as I push my code to my GitHub, the build pipeline stage automatically gets executed. Okay, all the things automatically get executed. ArgoCD automatically deploys my app, everything. Okay, as soon as I push. Okay, in Circle CI, in GitLab, these are by default option. You get a webhook in by default, but not here. You have to customize it. Okay, how you will do? Just go to your GitHub repo. Okay, whatever your GitHub repo is, just go to the settings. Okay, in the settings, in the left pane, you will find one option, webhooks. Okay, just create one webhook, add webhook. Okay, so it is showing you payload URL.
Now you have to pass one payload URL. How you will give your payload URL? You have to give your Jenkins URL basically. So this is your Jenkins URL. So just copy this much till your IP address and 8080 like this. Okay, paste it here and just go to your webhook and paste it here. So HTTP and 8080. Now after 8080, you will write GitHub hyphen web hook. Okay, GitHub hyphen webhook and uh, backslash. Okay, so this will be your payload URL. Now content type will be your application JSON, right? Secret, not necessary. You can avoid it and make sure it is enabled SS verification. And we want the push event. Okay, so just the push event. It means every time we push something to our GitHub repo, our pipeline will get executed. It will hit at our payload URL. Okay, so make sure it is active and add your webhook. Webhook added. You can see last delivery was successful. Now go to your GitOps project. Okay, just go to your dashboard and just open your pipeline, whatever pipeline you are working with. Just go to the configure. Okay, just a little bit scroll down and you will get uh, triggers. Okay, you have one webhook. Now to trigger that webhook, we want you have to click this GitHub hook trigger. Okay, because we have created a GitHub webhook. Okay, so just click it. Okay, uh, and just you have to do nothing else. Just apply, because we have already connected it to our GitHub repo previously only. So it knows automatically that this repo will be sending us the hooks. Okay, so you just have to enable this trigger, that is your GitHub hook trigger, and just apply and save. Okay, to show you the demo, let me open this screen here only. Okay, this is, I'm not clicking on the build now, but still let me open the VS Code. Let's make some changes. Okay, let's make some changes in the Jenkins file so that we can push our code. Let's make the change here in the stage name, ArgoCD CLI. Let's give it a name setup. Okay, okay, I'm giving it any random name so that it identifies any change. So now I will push git add, git commit, and git push. It has pushed the code. Now see the magic here. Okay, you can see automatically fifth your build got triggered. Okay, it has started building automatically, and you can just check console output, and it has started building, right? And once it gets successfully executed, your git argo cd will also get triggered. Okay, and the whole process will be automated. Now you don't have to do anything. Okay, as soon as you push something, it will automatically execute the pipeline, build it, sync it with your argo cd, deploy it. Okay, and after that you can access your app. Okay, for accessing, just go here, copy the external IP, and you have forwarded it to 9090. Just search 9090, and here is your app, and it will be continuously integrated deploying. And why we used Argo CD? Why so much hectic processes? Because it has its own advantage, and that advantage I have covered in the introduction video. Please watch the introduction video. I have told many things there. Okay, what we are doing, uh, each steps details and all. Okay, so with this, our project is now complete. We have perfectly deployed and all. We have done everything. Okay, you can see it is executing our pipeline, but let's skip this. Okay, now comes the cleanup processes. So you don't have to do anything. Just click on here and delete your VM instances. Okay, just click on this delete and your VM instance will get deleted. Otherwise, you will get charged. Okay, and the charge was quite high. I think it was around $110. Since it was for learning purpose only, so why to run it for infinite time? Just you can either suspend it also, okay, if you want, but I will say delete it so that you don't get extra charged. Just delete it and you will not get any charged.